you all can remember, you all can hear me clearly. So if you can't hear, please tell me. So in your first session, we discussed about mainly about the engines. And today what we are going to do is we are going to discuss about several systems of the tractors. So we are mainly focusing our study to the two tractors, two-wheel tractor and four-wheel tractor. So we are commonly going to discuss their systems now. මම හිතන්නේ පළවෙනි ඉතිේදී ඔයගොල්ලෝ මතක ඇති අපි එන්ජින් එකක් වැඩ කරන හැටි මූලිකව කතා කරා. ඒතර අපි අද කොටසේ කතා කරන්නේ මේ ට්‍රැක්ටර්ස් වල අපිට හම්බෙන මූලික පද්ධති පිළිබඳ. ඒකයි අපි අවසාන කොටසේ බලමු ට්‍රැක්ටරයක් මගේ පාවිච්චි කරන උපකරණ කොහොමද ට්‍රැක්ටරයක් භාවිතයෙන් ඒක සම්බන්ධ කරන ක්‍රියාත්මක කරන්න කියලා. So at the end, we'll discuss about the land preparation implements, and other implements can be operated with the help of tractors. So here I'm going to start from the fuel system. So we know in our country, most of the tractors, including two-wheel and four-wheel, so they have diesel fuel system. So they are having diesel engine, so they need diesel fuel system. So in the first part, what I'm going to discuss with you is, I will discuss with you about the diesel, the fuel system of a diesel two-wheel tractor. අපි දැන් මේකේ පළවෙනි කොටසට මොනව කරන්න යන්නේ ඔයගොල්ලෝත් එක්ක කතා කරන්නේ අපි ගත්තොත් අට්‍රැක්ටර් එහෙම නැත්නම් රෝඩ් දෙකේ ට්‍රැක්ටර් එක තියෙන ඉන්ධන පද්ධතිය කොහොමද වැඩ කරන්නේ කියන තමයි අපි කතා කරන්නේ. So I'm again telling you, we'll discuss about the operation of the fuel system, the diesel fuel system for two-wheel tractor. And I think you all can see here, here you can see the cross-sectional view of a diesel system of a two-wheel tractor. And here you can see the top one, there is a fuel tank. The function of this tank is to store fuel. අපි ගත්තොත් ඉන්ධන ටැංක් එකකින් කරන්නේ තෙල් ගබඩා කරලා පවත්වා ගන්නවා. To store the fuel is its function. And then you can see here there is a tap. So normally we use a tap to close a liquid system. So in our home also we are using the tap to close the water system, or to close the water we are using tap. So otherwise it flows out. So to stop the flow we are using a tap. So other than that, we can also, with the help of a tap, we can also control the flow, but the main function of a tap is to stop the flow. And here also, normally in engines, so except a situation where we need to repair, otherwise all the time we have to keep this tap as open. So only in case of a repair, we have to close this, because otherwise flow happens. So to stop the flow, we using a tap. So if there is any case of repair, we close the tap and do the repair. Otherwise, all the time we keep the tap as open. So then you can see there is a line, and then after the line you can see component. I think you all can see the component. I am highlighting it using the cursor. මම මේ පෙන්වන කොටසට කියන්නේ injector pump. Here you can see at the same time, if we take the internal part of this engine, I think you know these are the two timing wheels, crank timing wheel and cam timing wheel. So here if we take the cam timing wheel, at the end of that camshaft, there's another special cam. This is not used for the valve mechanism, but it is used to operate this injector pump. You will see how it is used to operate this injector pump. Keep that in mind. This cam is not used for operating valves, and here it is specially designed for operating the injector pump. මම හිතන්නේ ඔයගොල්ලන්ට මතකයි අපි timing wheels අරක දෙකක් කතා කරා, crank timing wheel, cam timing wheel. Cam timing wheel එක තමයි valve වලට සම්බන්ධ වෙලා valve අරින්න වහන්න උදව් කරන්නේ. එතකොට මේ cam shaft එකේම මේ two wheel tractor වල අමතරව එන විශේෂ cam එකක් එනවා. මේක valve වැඩ කරන්න ගන්න එකක් නෙමෙයි. මේ valve මේ cam එක පාවිච්චි කරන්නේ injector pump එක වැඩ කිරීම සඳහා පමණයි. අපි ඉස්සරහට බලමු කොහොමද මේ cam එක පාවිච්චි කරලා injector pump එක වැඩ කරන්නේ කියලා. Then after the injector pump, you can see there's another line that is known as injector line. Then that ends at another special component. That component is known as injector. So these are the main components. Fuel tank to store the fuel, tap to close the liquid system. Then there's a line to deliver fuel from tank to the injector pump, and then the injector pump. Here we are using the tractor uses an injector pump to pump diesel into the injector. I'm again telling, here the injector pump is used to pump diesel into the injector. Injector pump එක පාවිච්චි කරන්නේ injector with the diesel pump කිරීම සඳහා. And then if we take the injector, it is used to inject diesel into the cylinder. So the injector එක පාවිච්චි කරන්නේ diesel cylinder එක ඇතුළට විදීම සඳහා. ඒකම diesel cylinder ඇතුළට විදින විශේෂ අවස්ථාවක් තියෙනවා. ඒ කියන්නේ අපි engine cycle එක ගත්තොත් එක්තරා විශේෂ අවස්ථාවක් තියෙනවා. අන්න ඒ අවස්ථාවේදී විතරයි diesel cylinder ඇතුළට විදීම සිද්ධ කරන්නේ. So there is a specific point injector injects diesel into the cylinder. Can anyone remember that one? මම ඒක අර එන්ජින් එක ගැන කියද්දි කිව්වා කාට හරි මතක් වෙයිද මේ මොන අවස්ථාවේදීද අපිට ඩීසල් එන්ජින් සයිකල් එක ඇතුළේදී මොන ස්ට්‍රෝක් එකේදීද අපිට ඩීසල් සිලින්ඩර් ඇතුළට විදින්න ඕන කරන්නේ? Can anyone remember at which stroke, at which point of the stroke the tractor needs to inject
suction?
Suction. Am I correct? Is it suction? And also you can use the chat as well. අපි මොන වෙලාවෙද්ද අපිට diesel inject කරන්න ඕන වෙන්නේ? I think you know there are 4 strokes: suction, compression, power, and exhaust. During the suction stroke, if we take a diesel engine, it takes air into the cylinder. And during the compression, it compresses air, and there's a specific point. Can you remember that one? Suction එකේදී කරන්නේ අපි diesel ඇතුළට ගන්නවා නේද? What is given in the chat?
Compression.
Yes, very good, compression. And there's a specific point in the compression. Can you mention that one? Teshan has given us power, not the power, Teshan. The stroke is compression, but there's a specific point of that stroke. Can you mention that one? Is it at the beginning? Is it at the middle? Or is it at the end of the compression? Compression එක තමයි තෙල් අවශ්‍ය කරන වෙලාව. ඒතර මං අහන්නේ diesel අපිට ඉන්ජෙක්ට් කරන්න ඕන වෙන්නේ කම්ප්‍රෙෂන් එක පටන් ගන්නද කම්ප්‍රෙෂන් එක මැදදීද කම්ප්‍රෙෂන් එක ඉවර වෙද්දී at
Start
which
of the
point
compression.
sorry
Start of the compression.
Start of the compression means that is the point the piston starts to compress the air inside the cylinder. So what the engine has to do is at the maximum compression, if it can give diesel
Middle of the
into
compression.
the best point is at the end, no? That because that is the maximum compression point of the cylinder. So if the diesel can be injected into the cylinder at the maximum compression, then it creates a very good combustion. So keep that in mind. So injector, so I have given this one in our previous lesson as well. You can go through the note. So normally injector injects diesel into the cylinder just before ending the compression stroke. So keep that in mind. So if we take the exact point where the injection happens with regard to the engine cycle, that happens just before ending the compression stroke. Say hi, so disturbance when I never use the mic. Okay. Anyway. So you can use the chat or if it is hard, you can directly speak. So keep that in mind. Normally the injection happens just before ending the compression stroke. So we'll add everything now together and we'll discuss this one again. So here in this system, fuel tank, it is to store the fuel, then the tap to temporarily close the system, but it is totally open when it is working. And injector pump is to pressurize diesel into the injector, and then injector is used. Injector is for injecting diesel into the cylinder. There's a specific point for that. That is just before ending the compression stroke. So now we'll see how it works. So here, when the tap is opened, you can see fuel flow happens into the injector pump. And then C, it means when the engine is working means all these wheels are working. So see what happens inside the injector pump when the tractor is working. Right? මේ බලන්න injector pump එක ඇතුලේ tractor එක වැඩ කරනකොට සිද්ධ වෙන දේ. So now think it is working. So you can see at a point, I'm again showing you, at a point you can see if you consider about inside the injector pump, here you can see its internal volume going to be reduced. That increases the pressure, then the injector pump can pressurize diesel into the injector. So I'm again showing you that one. So the fuel is coming into the injector pump. And then see, when the engine is working, you can see because of this cam, it compresses inside the injector pump. That adds a pressure to the fuel, and then the pressurized fuel is given to the injector, and then injector injects diesel into the cylinder just before ending the compression stroke. මේ බලන්න මේ කැම් එක වැඩ කරලා ඒක මේ ඉන්ජෙක්ටර් පම්ප් එකේ වැඩනොත් ඉන්ජෙක්ටර් පම්ප් එක ඇතුලේ පරිමාව අඩු වෙලා පීඩනය වැඩි වෙනවා. එතකොට හරියටම මේ ඉන්ජෙක්ටර් ගාවේ ඉන්ජෙක්ට් කරනවා ඩීසල් සිලින්ඩරේ ඇතුළට ඒ සිද්ධ වෙන අවස්ථාව තමයි මොකද්ද? compression stroke එක ඉවර වෙන්න ඔන්න මෙන්න තියෙන අවස්ථාව. That is known as just before ending the compression stroke. So I'm again showing you. ඒතර මේක වැඩ කරනකොට අතුල ප්‍රෙෂරයිස් වෙනවා. ඒතර මේ ඉන්ජෙක්ට් කරන්නේ කම්ප්‍රෙෂන් ස්ට්‍රෝක් ඉවර වෙන්න ඔන්න මෙන්න තියෙන අවස්ථාව. So we'll now discuss the same thing in our working note as well. We working note එකත් මේකම කතා කරමු. So in the first session, what we are doing is we are going to discuss the tractor fuel system based on the two tractors, two-wheel tractor and the four-wheel tractor. හරි. අපි tractors දෙකට සාපේක්ෂව ඉන්ධන පද්ධති දෙක මූලිකව කතා කරනවා. එතකොට මේ ටික තමයි අපි මූලිකව කතා කරේ. So we are first discussing about the two-wheel tractor. රෝද දෙකේ tractor එකට සම්බන්ධව මෙන්න මේ කොටස් හතර අපි දැනට කතා කරලා තියෙනවා. මොනවද? The tank, that is to store diesel. Then there was a tap, that is to close the liquid store, but it is open throughout the operation. And then injector pump, I think you all can remember that one, that is to pump diesel into the injector. And I think you all have seen that one. The way it is working, there's a special cam which can compress inside the injector pump. Then that adds a pressure to the diesel, and that pressurized diesel then given to the injector. Then injector, that is the one the tractor uses to inject diesel into the cylinder. So that is its function. And if we can specify the exact point where the injection happens with regard to the engine cycle, that happens just before ending the compression stroke. So that point is very important because that can be directly given as one of your MCQs. ඒ කියන්නේ මේක MCQ එකක් විදිහට දෙන්න පුළුවන්. නිකන් උදාහරණයක් විදිහට ගත්තොත් injection happens. Choice number 1. Just before ending the compression stroke, just after ending the compression stroke, just before ending the power stroke, just before ending the suction stroke. Likewise, there may be options. The correct answer should be just before ending the compression stroke. Is it okay? මේ කියපු කොටස හැමෝටම තේරුණාද? So please continuously use the chat so then I can see the way how you are getting things, and if it is okay we can go for the next step. මේ කොටස තේරුණා නේද? අපිට තේරුණා නම් පොඩ්ඩක් yes කියලා කියන්න. ඒක කීප දෙනෙක් ආන්සර් આવොත් මම ඒක බලලා ඊළඟට යන්නගේ. Ishan to have given the answers. If someone says no, otherwise if someone is telling no, I think all have got it clearly. So then there's another small thing. The next thing is how this system works when increasing the engine speed. හරි අපි ඊළඟට බලමු මේ ඉතන පද්ධතිය කොහොමද වේගය වැඩි කරනකොට එයා එන්ජින් එකට උදව් කරන්නේ වේගය වැඩි කරගන්න කියන එක. Normally if we take ඔයගොල්ලන්ට මේ ප්‍රැක්ටිකල් එකේදී ගොඩක් වෙලාවට බලන්න පුළුවන් වෙයි. අපි two-wheel tractor එකක් ගත්තොත් two-wheel tractor engine එකක් ගත්තොත් මේකේ accelerator එක මෙන්න මේ වගේ යාගේ වේගය පාලනය කරන කොටසක් සම්බන්ධ වෙලා තියෙනවා. So it means the engine has this type of small unit which indicates low and high, that is for engine speed, and it is directly connects with the accelerator of the two-wheel tractor. It means when the tractor is at very low speed, normally this lever is at low position. If we need to increase the speed, what we have to do is we have to press the accelerator. When the accelerator is being pressed, what happens is this lever usually comes to the high position. අපි සාමාන්‍ය accelerator එකේ වේගය වැඩි කරනකොට වෙන්නේ මේ lever එක low position එකේ ඉඳන් high position එකට එනවා. So simply if we are running with a very slow speed, usually this lever is near to somewhere around here. So if we are accelerating or if we are running with a very high speed, then usually this lever stands near to this high position. වේගින් යනකොට මේ lever එක තියෙන්නේ high පැත්තේ, slow ට තියෙනකොට තියෙන්නේ low පැත්තේ. And see, now the system works at a very low speed. Right? අපි බලමු දැන් මේක තියෙන්නේ සාමාන්‍යයෙන් අඩු වේගයකින් යනවා නම් මෙන්න මේ වගේ එකක් තියෙන්නේ කියලා අපි මූලිකව හිතමු. So to explain that one, what I'm going to do here is I'm going to make few cross sections. I think you have seen that once. So I'm going to consider these cross sections. And if you can see these cross section like this. අපි මෙන්න මේ තැන් දෙකෙන් හරස් කැපුමක් මේ එන්ජින් එකේ කරොත් ඒකේ අපිට ඕන කරන කොටස ඔයගොල්ලන්ට මෙන්න මේ වගේ පේනවා. මෙන්න මේ එහා පැත්තේ මම මේ කර්ස් එක ගෙනියන තැන පේන විදිහට තමයි අපි මේ ඉන්ජෙක්ටර් පම්ප් එකේ ක්‍රොස් සෙක්ෂන් එකක් ගත්තොත් අපිට මෙන්න මේ වගේ එයාව පේනවා. So if we can make a cross section here, then we can see it like this. You will have get this. You will have taken that one. මෙතනින් කැපුවොත් ඒක පේන්නේ මෙන්න මේ වගේ. So we'll see now the injector, now the system is at low fuel delivering position. දැන් engine එක තියෙන්නේ මෙන්න මේ අවස්ථාවේ කියලා. So now at this point, if we can see the injector pump, it looks like this. Right? And මේ වෙලාවේ injector pump එක බැලුවොත් injector pump එක වෙන්නේ මෙන්න මේ වගේ. We'll see how the things are going to be changed if we can move this lever from low position to the high position. So now what I'm going to do is I'm going to make this position and see inside another thing inside the injector pump. This is the total amount of diesel at this position the pump can take into the injector pump. Now it can take in to the injector pump, that is this much of fuel. So පේනවාද මෙන්න මේ තරම් ප්‍රමාණයක් තමයි මෙයාට දැන් ඇතුළට ගන්න පුළුවන් වෙන්නේ. And we'll see what happens if if we need to increase the engine speed. So we have to move this lever from low to high. දැන් මේක ඕන කරනවා low වල ඉඳන් high වලට ගිහින්. ඇතුළත් මේ lever එක මෙතන ඉඳන් මෙතනට ගියේදී බලන්න ඇතුළේ සිද්ධ වෙන දේ. So I'm moving it to high. I'm again showing you. Now it has been moved to the high position. Can anyone tell what has happened inside the injector pump? Injector pump එක ඇතුලේ මොකද වුනේ කියලා කාට හරි කියන්න පුළුවන්. I'm showing you. This is how it works at the low position. And see the injector pump. This is the amount of fuel it can take at the low position. And what we are doing is, I'm going to change this into high position. 5 වලට දානවා. 5 වලට leave එක එනකොට හොඳට බලන්න කාට හරි කියන්න පුළුවන්ද කියලා what has happened inside the injector pump. Injector pump එක ඇතුළේ මොකද වෙලා තියෙන්නේ? කලින් අවස්ථාවට සාපේක්ෂව. Can anyone tell? Injector pump එක ඇතුළේ බැලු බැලමට මොකද වෙලා තියෙන්නේ කලින් අවස්ථාවට සාපේක්ෂව? What has happened inside the injector pump with compared to the previous low position? It's very good. I think that has given by Shehari. You can see clearly now the injector pump's internal volume has been increased. It means now the system can grab more fuel. It means the engine can produce more power and then the tractor can increase its speed. Injector pump එක ඇතුළට තෙල් ප්‍රමාණය වැඩියෙන් එනවා. So now injector pump can pump more fuel into the injector. If there are more fuel means the engine can produce more power. Power is directly proportionate to the speed. So now the tractor can move at a very high speed than it was before. බලය වැඩිපුර හම්බෙනවා කියන්නේ වේගය වැඩි වෙනවා. ඒ හින්දා tractor එක අර low තිබුණ අවස්ථාවට වඩා වැඩි වේගයකින් දැන් ගමන් කරන්න පුළුවන් වෙනවා. I think 2 has given the answers. Volume was increased. No? Very good. So we'll add that one to our working note. මේකත් අපි working note එකට දාගමු. So here, now you can see, I think what we have discussed here, the accelerator can be discussed. The way the accelerator can control the injector pump, actually it can control the internal volume of the injector pump. So that was like this, when the accelerator at low level, I think we have seen this one, the injector pump can hold quite a low amount of diesel, but when it is accelerated, that lever can be moved into high position. When it is moving into high means internally there's a change is happened. It means internally injector pump can grab more fuel actually than it was before, means than it was at the low level. So then when doing the acceleration, now the system can, or the injector pump can grab more fuel, then it can provide more fuel to the cylinder, means generation, a big power. Power is proportionate to the speed of the tractor. So now the tractor can go at a faster speed than it was before. So usually the fuel system provides now more fuel to the cylinder when engine is accelerated into higher speeds. So these are the 3 points just now we have discussed, because I think I have shown you accelerator, there's a connection between the accelerator and the injector pump. When the accelerator is at low position, it can grab quite a low amount of fuel. And when it is accelerated, at that point, injector pump can grab more fuel. Grabbing more fuel means it can provide more fuel to the cylinder, means creating a huge power than it was at the low level of giving fuel. අපි ගත්තොත් accelerator ඉන්ධන පද්ධතිය අතර සම්බන්ධයක් තියෙනවා. එතකොට injector pump එකේ වෙනසක් කරන්න පුළුවන් accelerator එක පාවිච්චි කරලා. එතකොට අඩු අවස්ථාවේදී එන්නේ අඩු තෙල් ප්‍රමාණයක් accelerate කරනකොට ඉන්ධන පද්ධතියට වැඩි තෙල් ප්‍රමාණයක් ඇවිල්ලා ඉන්ධන පද්ධතිය තුළින් මේක වැඩි කරගන්න පුළුවන් වෙනවා. That is all about the two-wheel tractor. Is it clear? How about the last point? The things how things happen when doing the acceleration. Is it clear? වේග වැඩි කරනකොට ඉන්ධන පද්ධතිය ඇතුළේ සිද්ධ වෙන දේ හැමෝටම පැහැදිලියි. What has happened during the acceleration? Is it clear for you? වෙන දේ පැහැදිලිද? Accelerate කරන වෙලාවෙන් සිද්ධ වෙච්ච දේ හැමෝටම පැහැදිලියි. Is it clear or do we need some more explanations? මොකද වෙන්නේ? මේ අපිට කැලේ හැමෝටම තේරුණාද? Is it okay? If it is okay, we can move to කාටරි තේරුම් නැත්නම් no කියලා කියන no කියලා කිව්වොත් මම ආයෙ පාරක් පැහැදිලි කරන්නම්. එහෙම නැත්නම් මම ඉස්සරහට යනවා. ඒ කියන්නේ මම හිතන්නේ හැමෝටම තේරෙනවා කියලා. So yes. So now we can move to the next part. That is about how the fuel system looks like in a four-wheel tractor. බලමු ඊළඟට four-wheel tractor එකේ මේක කොහොමද තියෙන්නේ කියලා. This is how it looks like in a four-wheel tractor. And before that one, I have to mention us very few things. So if we consider a two-wheel tractor, inside the engine there is only one cylinder. But if we consider a four-wheel tractor, normally most of the four-wheel tractors in our country, they have 3 cylinders in their engines. Right? So ගොඩක් වෙලාවට ගොඩක් තියෙන tractors ගත්තොත් engine එක ඇතුලේ ගොඩක් වෙලාවට cylinders 3ක් 3 or more. Usually the number is 3. Right? එතකොට cylinder එක ඇතුලේ කියන්නේ engine එක ඇතුලේ ඒගොල්ලෝගේ cylinders 3ක් හෝ ඊට වඩා වැඩි ගාණක් තියෙනවා. ගොඩක් වෙලාවට තියෙන cylinders 3. It means earlier it was only one. But now you can see, if we take a four-wheel tractor, now it has 3 number of cylinders. Definitely, the system should be larger than in a two-wheel tractor. Larger than the two-wheel tractor. Fuel system. So, මොකක්ද අනිවාර්යයෙන්ම වෙන්න ඕනේ? Two-wheel tractor එකේ තියෙන diesel system එකට වඩා four-wheel tractor diesel system එක අනිවාර්යයෙන්ම ලොකුයි. Since it is bigger than the two-wheel tractor system, the operation is also somewhat complex than the two-wheel tractor system. එතකොට ලොකු වෙනවා කියන්නේ ඒකේ එකක් ප්‍රමාණයෙන් විශාල වෙනවා ඒ එක්කම ක්‍රියාවලිය ටිකක් සංකීර්ණ වෙනවා two-wheel tractor එකට සාපේක්ෂව. The system is bigger with compared to a two-wheel tractor system, as well as the operation is bit complex than that is in a two-wheel tractor. Right? Four-wheel tractor එකේ ඉන්ධන පද්ධතිය ගත්තොත් two-wheel tractor එකට වඩා ටිකක් ලොකුයි. හැබැයි ලොකු වෙනවත් එක්කම යාගේ ක්‍රියාවලිය ටිකක් විතර සංකීර්ණ වෙනවා. Earlier in two-wheel tractor system, just using the gravitational force, fuel can move into the injector pump But in diesel four-wheel tractor, that is not much possible because the system is bigger. Here, additionally, we need a fuel pump to pump fuel into the injector pump. ඒක තමයි පළවෙනිම දේ. අර කලින් කරා වගේ කෙලින්ම ගුරුත්වය යොදාගෙන තෙල් ඉන්ජෙක්ටර් පම්ප් එකට ගමන් කරන්න බෑ four wheel tractor එක. So we need an additional fuel pump for doing that. හරි. අපිට එතකොට fuel pump එකක් ඕන කරනවා ඔය කියන දේ සිද්ධ කරන්න. ඊට පස්සේ තව එක දෙයක් වෙනවා මේ two wheel tractor එක ටිකක් ලොකු four wheel tractor එක ලොකු හින්දා since the system is bigger, fuel can be contaminated because of two main things. When the fuel is within the system, it can be easily contaminated due to two main things. එතකොට පද්ධතිය ඇතුලේ ඉන්නකොට එයා ඉක්මනට මේ එයාගේ quality එක අඩු වෙන්න පුළුවන් දේවල් දෙකක් නිසා. Its quality can be reduced because of two main things. Can anyone guess what are those two things? කියන්න පුළුවන්ද? Yes, I think it is a bit complicated one, but I will make it simple for you, okay? අර මං අහපු දෙයට චූටි උත්තරයක් දෙන්න පුළුවන්ද? තෙල් සිස්ටම් එක ඇතුලේ තියෙද්දි මොනවෙන්ද තෙල් නරක වෙන්න පුළුවන්? තෙල් වල quality අඩු වෙන්න දේවල් දෙකක් එකතු වෙන්න පුළුවන්. මොනවාද? Can anyone mention? තෙල් ඇතුලේදී quality එක අඩු වෙන්න මොනවද එකතු වෙන්න පුළුවන්? සිස්ටම් එක ඇතුලේදී. නිකන් guess කරන්න පුළුවන්ද? මොනවා වගේ dust. Very good. Shahari. Another one? So these are metal tubes and metal lines. So inside these metal parts, definitely fuel is contaminated due to dust particles. A very good answer. Dust is one major thing. Other than dust, there's another major one. So normally when we are operating these tractors at midday, so normally we have very high temperatures. So most of the time, if we consider inside the fuel tank, there's another answer. Yes, very good, sharing water. So the two things that make fuel contaminated are dust and water. If you take dust, because these are metal parts, inside the metal parts, usually there's rust and dust. So then that is how dust can come into the fuel. If you take water, that mix. If you take water, that is going to mix like this. So normally when we are working at the midday, we are having very high temperatures. Usually inside the fuel tank, we can see moisture as vapor. අපි දවල්ට ට්‍රැක්ටර් එක වැඩ කරනකොට ටැංකිය ඇතුලේ ජල වාෂ්ප තියෙනවා. හැබැයි අපි වැඩ ඉවර කරලා හවස ට්‍රැක්ටර් එක පාක් කරපුවම, so after parking the tractor at the end of the work during evening, with compared to midday, now there's a significant decrease in the temperature, especially inside the fuel tank. That decrease of temperature makes water condense. එතකොට දැන් අර එකපාරට උෂ්ණත්වය අඩු වෙනකොට වෙන්නේ ඇතුලේ වාෂ්ප වගේ තියෙන ජලය ඒක ඝනීභවනය වෙලා they are going to be condensed into water droplets. ඒක condense එකට වෙන්නේ එයා ඝනීභවනය වෙලා ජල බිඳු බවට පත් වෙනවා. දැන් ටැංකිය ඇතුලේ මේ දේ සිද්ධ වෙන්නේ. එතකොට අර ජල බිඳු ටික කෙලින්ම ගිහිල්ලා එකතු වෙන්නේ තෙල් වල. So that is how water is mixed to the fuel. So anyhow, you have to remember there are two things which can contaminate fuel. They are dust and moisture, or dust and water. So keep this in mind because this also can be given as one of your MCQs. The two things which can contaminate diesel inside the fuel, inside the fuel inside the system. So, since there are two things, yes, vapor become liquid. That is the reason for adding water into the fuel. I think Sherry has given it clearly. Vapor become liquid. Yes, it is correct. So now the system has to do another additional thing before giving diesel into the injector pump, because now it has been contaminated. So now the system has to purify it. So here the fuel system uses special filters known as primary and secondary to remove dust and water. Okay, and there's another thing. දැන් ෆිල්ටර්ස් වර්ග දෙකක් තියෙනවානේ. ඒකටත් පොඩි හේතුවක් තියෙනවා. අපි හිතුවොත් නිකන් හිතන්න, now you are cleaning your houses, okay? And think on the floor there are a lot of dust. And think accidentally we have spilled some water on the dust. Assume that you are sweeping your floor, and on the floor there are a lot of dusts, and accidentally you have spilled some water on the dust. Can anyone tell what is the best way of cleaning that floor now? බිම කුණු තියෙනවා, දූවිලි ගොඩාක් තියෙනවා බිම. ඒ උඩට වැරදිලා වතුර එකක් වැටෙනවා. දැන් ඔය කුණු ගොඩ උඩ දූවිලි ගොඩ උඩ වතුර තියෙනවා. කාට හරි කියන්න පුළුවන්ද the best way of cleaning that one? ඕක අපි වැඩි ගා ගන්න නැතුව හොඳට ක්ලීන් කරොත් කරන්න පුළුවන් විදිහ මොකක්ද? On the dust now there is water as well. අපිට කොහොමද කරන්න පුළුවන්? මං කියව එක තේරුණාද නේද? එතන පොළවේ ඩස්ට් එක තියෙනවා. ඩස්ට් එක උඩට වතුරක් වැටලා තියෙනවා. දැන් වතුරයි ඩස්ට්ුයි එකට තියෙනවා. මේක වැඩි ගා ගන්න නැතුව හොඳට ක්ලීන් කරනවා නම් කොහොමද අපි ක්ලීන් කරන්න පුළුවන්? පළවෙනි දේ මොකක්ද කරන්න ඕනේ? දැන් ඩස්ට් එක උඩ වතුරක් වැටිලා තියෙනවා. මේක හොඳට ක්ලීන් කරන්න නම් අපි ඉස්සල්ලා මොකක්ද කරන්න ඕනේ? What should be the first thing? Do we need to deal with dust or do we need to deal with water? අතු ගන්නවා නම් මොකද වෙන්නේ? අපිට මොකක්ද කරන්න ඕන වෙන්නේ? ඒක තමයි දැන් පොළව අතු ගන්නකොට දූවිලි තියෙනවා. ඒක උඩට වතුරක් වැටිලා. දැන් වතුරයි දූවිලි දෙන්නම එකට ඉන්නේ. අපිට දැන් කොහොමද මේක සුද්ධ කරනවා නම් ඉස්සෙල්ලා මොකද කරන්න ඕනේ? අපිට ඉස්සෙල්ලා අයින් කරන්න පුළුවන් ලේසියෙන්ම මේක කරන්න පුළුවන් වතුර අයින් කරලාද ඩස්ට් එක අයින් කරලාද? දැන් උගාන නැද්ද කවුරු? ඉතින් කොහොමද අයින් කරන්නේ දැන්? Very good, Mohammed. I think first we have to anyhow either using a fan or anything we better think we need to sponge water first. Or we have to remove, first we have to, yes, prevent spread. So we have to first absorb the water. First we have to dry the water, then we can easily remove the dust particles. Otherwise, the thing will become a mess. මම හිතනවා අපිට ඒක ලේසියම නේද දැන් උඩ ටයිල් එක උනත් ටූවිල් කීදී වතුර හැරෙනොත් ඉස්සෙල්ලා පොඩ්ඩක් ඒව ඩ්‍රයි වෙන්න තිබ්බොත් වතුර ටික අයින් වෙන්න තියලා පස්සේ අතු ගෑවොත් ලේසියෙන් කරන්න පුළුවන්. හැබැයි දෙකම එකට තියෙද්දි අතු ගන්න ගියොත් ඒක නිකන් මික්ස් අප් වෙලා එච්චර අයින් කරන එක අමාරු වෙනවා. So here the system also do the same concept. So now we have both things, dust and water. So there are two filters, primary filter and secondary filter. By taking that concept, can anyone tell what is the exact function of the primary filter and what is the exact function of the secondary filter? Primary filter ke secondary filter ke functions එක කාට හරි කියන්න පුළුවන්. Using that concept, removing dust and water. What do you think? What is the function of the primary filter? Primary filter එකකින් මොනවද කරන්න වැත්තේ තෙල් වල තියෙන්නේ? Can anyone tell? Because the filters are for removing dust and water. So I'm asking, can anyone guess what is the function of the primary filter? Yes, I think Nihiranga, I think he has given the answer correctly. So we are using primary filter, Mohammed, very good. Primary filter to remove water. Primary filter to remove moisture. And then we are using a secondary filter to remove dust. So keep that in mind. This fuel system has two separate filters. Primary filter for removing water, that is also known as water separation filter. And then the secondary filter is to remove dust. I think now it is clear to you. There are two filters, primary filter to remove water, secondary filter to remove dust. Then the purified fuel is given to the injector pump. So you can see here now, and there's a tap, and that gives to the fuel pump, then removing water, then removing dust. Then the purified fuel is given to the injector. So I told you, not like in the two-wheel tractor, now the tractor usually it has 3 cylinders. Now it has 3 number of cylinders. So since it has 3 cylinders, there should be 3 injectors as well as 3 separate injector lines. So you can see them. Here you can see this is a 1 injector line and an injector, second injector line and the injector, third injector line and the injector. There should be 3 injector lines for 3 separate injectors. And now the concept is same as before, means as it was in the two-wheel tractor, the injector pump has to inject in a pump fuel into the injectors. Then the injectors are injecting diesel at 3 separate points of time. So they are anyhow in each cylinder just before ending the compression stroke. Each injector injects diesel into the cylinder. So but here the injections happen at 3 separate times, but it happens just before ending the compression stroke in each cylinder. මෙතන cylinders තුනක් තියෙනවා. cylinders තුනේ power stroke අවස්ථා තුනකදී තමයි ඇති වෙන්නේ. කවදාවත් සිලින්ඩර්ස් තුනේම power stroke තුන එක ළඟ ඇති වෙන්නේ නැහැ. ඒ හින්දා ඉන්ජෙක්ට් කරනකොටත් සිද්ධ වෙන්නේ එකම අවස්ථාවේ නෙමෙයි වෙන අවස්ථා තුනකදී තමයි ඉන්ජෙක්ෂන් සිද්ධ වෙන්නේ. හැබැයි එන්ජින් සයිකල් එකකට සාපේක්ෂව හැම සිලින්ඩරේම injection සිද්ධ වෙන්නේ just before ending the compression stroke. So we'll see that one. So this is how the injection happens in the first cylinder, second cylinder, and in the third cylinder. So the injection happens at 3 separate times, but with regard to the engine cycle in each cylinder, that happens just before ending the compression stroke. හරි. ඒ කියන්නේ සිලින්ඩර්ස් තුනක් තියෙනවා. අනිවාර්යෙන් අවස්ථා තුනකදී තමයි ඉන්ජෙක්ෂන් සිද්ධ වෙන්න ඕනේ. හැබැයි ඉන්ජෙක්ෂන් එක අපි සිලින්ඩර් එක එන්ජින් සයිකල් එකකට සාපේක්ෂව ගත්තොත් කලින් කතා කරා වගේමයි compression stroke එක අවසාන මෙන්න තියෙන අවස්ථාව. Just before ending the compression stroke, injection happens. So you can see we have completed the major fuel lines. But here you can see there are some additional lines. There's another small reason for that. So just forget about the fuel system. Think now you are studying for your exam and think you need a B plus. Okay? Think that and in your exam you need a B plus pass. So when you are studying for that, what you have to do is to obtain a B plus, you have to at least work for A or A minus. I think, is it clear for you? අපි සාමාන්‍යයෙන් ඕනම වැඩක් කරනකොට අපිට මොකක් හරි ටාගට් අපේ එක්සැක්ට් ටාගට් එකක් තියෙනවා නම් ඒක හරියටම ඒ ටාගට් එක අපිට ගන්න නම් අපි ටාගට් එකට වඩා ටිකක් වැඩියෙන් මහන්සිලා වැඩ කරන්න ඕනේ. The fuel system does the same. Assume that for a particular injection, if we take 0.5 milliliters per injection, අපි ගමුකෝ එක අවස්ථාවකදී ඉන්ජෙක්ට් කරන්න ඕනේ 0.5ක් diesel. What the system does is injector pump gives more fuel to the injector. It means if for the injection, injector assume if it injects 0.5 milliliters to the cylinder, injector pump gives usually 0.7 milliliters to the injector. උදාහරණයක් විදිහට ගන්නකො ඉන්ජෙක්ටර් එකෙන් අපි හිතන්නකො 0.5ක් ඉන්ජෙක්ට් කරන්න ඕනේ කියලා. එතකොට ඉන්ජෙක්ටර් පම්ප් එක කරන්නේ 0.5ට වඩා වැඩි. උදාහරණයක් විදිහට එයා 0.7ක් ඉන්ජෙක්ට් එකට ලබා දෙනවා. So at the end of the injection, there should be remaining of 0.2 milliliters of diesel. So if there are 3 injectors, there should be 0.6 milliliters of diesel. So keep that in mind. These are diesel. So it is costly thing. So what the system has to do is, again, it has to use that additional amount of diesel remaining at the injector level. So the system එකට කරන්න වෙන්නේ එයාට මේ වැඩිපුර දීපු තෙල් ටික ආය පාරක් පාවිච්චි කරන්න ඕන කරන්න. Same to the injector pump. So assume that we are assuming that per injector it has given 0.7 milliliters. So altogether for 3 injectors there should be 2.1 milliliters of diesel. For giving 2.1 milliliters of diesel, filters are giving more than that amount to the injector pump as well. The injector pump එකෙන් injectors තුනට 2.1ක් diesel දෙන්න නම් අර වගේම filters කරන්න injector pump එකට 2.1කට වඩා වැඩිපුර තෙල් ප්‍රමාණයක් ලබා දෙනවා. So then at the end what happens is at injector level there's additional amount of there are remaining diesel. At the injector pump level as well there are remaining amounts of diesel. So there's another mechanism to redirect that excess diesel either into the tank or to the filters. So that is done by a special fuel lines, that those lines are known as reverse flow or overflow fuel lines. එතකොට injectors ගාවත් වැඩිපුර තෙල් ඉතුරු වෙනවා. injector pump එක ගාවත් වැඩිපුර තෙල් ඉතුරු වෙනවා. මේක කරන්න ඕනේ මේ වැඩිපුර තෙල් ටික we have to redirect either into the fuel tank or into the fuel filters. So you can see, so this is the first overflow line connecting connecting the excess amount remaining at the injector pump again back to the fuel filter. So that is given in orange color. That is the overflow line in the injector pump. So this is the one. So you can see this is the one recollecting excess fuel and redirecting that excess fuel into the fuel filter. This orange color line is known as an overflow line. And there's another overflow line connecting injectors and the tank, or connecting those fuel and reconnecting them again into the filter. So this is second line, you can see connecting all the excess fuel in the injectors, and it comes to a junction here. Then from this junction onwards, either it can move directly to the fuel tank or to the secondary filter. So you can see here, there are two overflow lines. One is from injector pump to the secondary filter. And then at the injector level, there's another overflow line which collects all the excess diesel at the injectors and redirecting either into the fuel tank or to the secondary filter. So injectors වල ඉතුරු වෙන අතිරික්ත තෙල් ටික එකතු කරලා එක්ක ගෙනෙනවා කෙලින්ම ටැංකියට. එහෙම නැත්නම් ආය පාරක් එයා දෙනවා secondary fuel filter. Because this is fuel and it has to be reused. Either it is given as a excess one, the system has to use it again. So that for doing that, it has overflow lines. The function of those overflow lines is to redirect that excess fuel either into the fuel tank or into the secondary filter. Then the system can reuse that excess fuel again. I think that is all about the four-wheel tractor fuel system. So we'll go to our working note again. We'll discuss it at the working note again. Working note again. So here you can see in our working note, components discussed under four-wheel tractor diesel fuel system. So here we are discussing things in addition to the components what we discussed under the two-wheel tractor diesel system. So as I mentioned you, I think you can see this one. So as I mentioned you before, a four-wheel tractor fuel system is bigger in size and complex in operation than that of the two-wheel tractor. Because it is bigger in size, because of that extended size, the operation also is somewhat complex than that was in the two-wheel tractor. Because we know four-wheel tractor has 3 number of cylinders, size is bigger, so to facilitate those 3 cylinders, now the fuel system has to be bigger in size as well as complex in operation. So we'll discuss now its components. So in addition to the things what we have discussed in the two-wheel tractor fuel system, so we know it has a fuel pump that is to pump fuel from the tank into the injector pump through the filters. And in case of filters, there are two filters: primary filter, that is to separate water, and secondary filter, that is to separate dust, because these are the two things which can contaminate diesel while it is in the fuel system. And then, so here again, water separation filter, that is the primary filter, dust separation filter, that is the secondary filter. And then there was another special line that is known as overflow lines, and those lines are to recollect excess amount of diesel provided to the injector pump as well as to the injector, and then they are going to resend those excess diesel either to the tank or to the secondary fuel filter. So they are redirecting that excess fuel either to the tank or to the secondary filter. So these are the things what we have discussed in addition to the two-wheel tractor fuel system. Is it clear to you? So how about it? Is it clear? මේ කොටස් ටිකයි overflow line එකක් කියන්නේ මොකද්ද? filters වලින් කරන්නේ මොනවද? ඔය කොටස ඔයගොල්ලන්ට පැහැදිලි. Is it clear to you how the filters are working? Then the basic function of the overflow line. Are they clear to you? Okay, Shahan, yes. So please, if it is not clear to you, please give it here. So then I will explain you again. So overflow line, can you explain? Yes, I can do. So here it is like this. So if we take overflow lines like this, we got the සාමාන්‍යයෙන් මෙහෙමයි. දැන් අර මම අර කලින් කිව්වා වගේ අපි අර මොකක් හරි ටාගට් එකක් තියනවා නම් ඒක අපිට ටාගට් එක හරියටම ටාගට් එකට ලඟ වෙන්න ඕන නම් අපි ටාගට් එකට තියනට වඩා වැඩිපුර දෙයක් කරන්න ඕනේ. උදාහරණ තමයි අපිට B+ එකක් ඕන නම් අපි ඒකට A+ එකක් ගන්නවත් වැඩ කරන්න. ඒකට අපිට හරියටම කියන්න පුළුවන් අපිට B+ එකක් හම්බ වෙනවාමයි කියලා. fuel system එකත් ඔය වැඩේම කරනවා. මොකද්ද? අපි හිතමුකෝ එක වෙලාවකදී ඉන්ජෙක්ට් කරන්න ඕනේ අපිට 0.5 මිලිලීටර්ස් ඕන නම් ඉන්ජෙක්ට් කරන්න. ඉන්ජෙක්ටර් පම්ප් එක කරන්නේ ඉන්ජෙක්ට් එකට 0.7ක් විතර දෙන්න. එතකොට එතන වැඩිපුර 0.2ක් ඉතුරු වෙනවා. එතකොට අපි මෙතන ගත්තොත් ඉන්ජෙක්ටර්ස් 3ක් තියෙන හින්දා එකපාරක් ඉන්ජෙක්ෂන් එක ඉවර වෙනකොට 0.6ක් මිලිලීටර්ස් මේ ඉන්ජෙක්ටර්ස් තුනේම ඉතුරු වෙනවා. ඕකම ඉන්ජෙක්ටර් පම්ප් එකෙන් ඒ කියන්නේ 0.7ක් එක වෙලාවක 0.7ව 3ක්. ඒ කියන්නේ මිලිලීටර් 2.1ක් ඉන්ජෙක්ටර්ස් වලට ලබා දෙන්න නම් ෆිල්ටර්ස් කරන්නේ ඉන්ජෙක්ටර් පම්ප් එකට මිලිලීටර් 2.1ක් නෙමෙයි, යා 2.5ක් විතර වැඩිපුර ඉන්ජෙක්ටර් පම්ප් එකට ලබා දෙනවා. එතකොට අනිවාර්යයෙන්ම දන්නවා ඉන්ජෙක්ටර් පම්ප් එකට 2.1ක් ඉන්ජෙක්ටර්ස් වලට ලබා දෙන්න පුළුවන්. දැන් වැඩේ වෙන්නේ ඔය අවස්ථා දෙකේදීම එක වෙලාවකදී ඉන්ජෙක්ටර්ස් වලත් තෙල් ඉතුරු වෙනවා වැඩිපුර, ඉන්ජෙක්ටර් පම්ප් එකෙත් වැඩිපුර තෙල් ඉතුරු වෙනවා. මේ ඉතුරු වෙන තෙල් ටික කරන්න ඕනේ අපිට ආය පාරක් එක්කෝ ඉන්ධන ටැංකියට මේවා ආය පාරක් වැඩට ගන්න ඕනේ. එහෙම ගන්න නම් මේ ටික එක්කෝ ඉන්ධන ටැංකියට ආය පාරක් ගමන් කරවන්න ඕනේ. එහෙම නැත්නම් ආය පාරක් ෆිල්ටර් එකට ගමන් කරවන්න ඕනේ. මොකද ෆිල්ටර් එකට ගියත් ටැංකියට ගියත් ආය පාරක් වෙන්නේ ඉන්ජෙක්ටර් පම්ප් එක හරහා මේවා ඉන්ජෙක්ටර්ස් තුනට ලබා දෙන්න පුළුවන්. මෙන්න මේ ලබා දීම කියන්නේ ඉන්ජෙක්ටර්ස් වල ඉඳන් එක්ක ටැංකියට හරි ෆිල්ටරේට හරි එහෙම නැත්නම් ඉන්ජෙක්ටර් පම්ප් එකේ ඉඳන් ආය පාරක් ෆිල්ටරේට ලබා දෙන ලයින් වලට අපි කියනවා overflow or reverse flow lines කියලා. overflow line එකකින් කරන්නේ අර වැඩිපුර තියෙන තෙල් ටික අරගෙන ඉන්ජෙක්ටර්ස් වල ඉන්ජෙක්ටර් පම්ප් එකේ තියෙන වැඩිපුර තෙල් ටික අරගෙන එක්ක ටැංකියට හෝ එක්ක ළඟම තියෙන ෆිල්ටරේට ලබා දෙන නානවලට තමයි අපි කියන්නේ overflow lines කියලා. මොකද නැහැ තේරුණාද? Is it okay? Miranda? I think, is it? Yeah, okay. Okay. So we have now completed the things what you should know about the tractor fuel systems. And now then we'll have the high. Shall we have a 15 minutes break? Shall we start again by 10:30? Is it okay?
Okay, sir. Thank you.
With higher theatre time. In the second part, we are going to discuss about the petrol fuel system. If we take a grass cutter, normally we have a petrol fuel system. So likewise, there are several agricultural implements, especially the small machines. So they have petrol fuel system. So here in petrol fuel system, it has a one specific component, one unique component that is known as carburetor. Because in petrol engines, during the suction stroke, instead only air, we have to provide air fuel mixture to the cylinder. අපි petrol engine cycle එක ගත්තොත් suction stroke එකේදී diesel engine එක නම් suction stroke එකේදී ලබා දෙන්නේ වාතය පමණයි. හැබැයි අපි ගත්තොත් petrol engine එක suction stroke එකේදී ඉන්ධන වාත මිශ්‍රණයක් තමයි ලබා දෙන්න ඕනේ. ඔය කියන ඉන්ධන වාත මිශ්‍රණය අපි හරිගස්සලා දෙන විශේෂ කොටසට කියනවා carburetor එක කියලා. So the petrol engines have a unique component in their fuel system that is known as carburetor, which is for mixing air and fuel together, and then it gives into the cylinder during the suction stroke as an air fuel mixture. So here, to know the concept, so there is a special concept in this carburetor that is known as Bernoulli concept. මේ carburetor එක වැඩ කරන්නේ Bernoulli කියන concept එක පාවිච්චි කරලා. And here you can see three barometers, and there's a tube, and at a point it has a diameter restriction. That point is known as venturi. මේක තියෙන්නේ සරල tube එකක් තියෙනවා. ඒ tube එකේ එක තැනක එයාගේ නිෂ්කම්භය අඩු කරලා තියෙනවා. එතකොට මේ එහෙම විෂ්කම්භය අඩු කරපු විශේෂ නලයකට අපි කියනවා වෙන්චූරි නලයක්. එහෙම නැත්නම් වෙන්චූරි tube එකක් කියලා. Because at a point it has a diameter restriction. That is why it is known as a Venturi tube. එතකොට මේ Venturi tube එකේ තැන් තුනකින් barometers තුනක් හයි කරලා තියෙනවා. So you can see here there are three barometers. A barometer means a one which has mercury inside it, and it can be used to measure internal pressure. මේ barometer කියන එකේ වාසිය තමයි වැදගත්කම තමයි මේ barometer එකේ තියෙන රසදිය. මේක barometer එකක් පාවිච්චි කරලා අපිට අභ්‍යන්තර පීඩනයක් යම් කිසි දෙයක හොයාගන්න පෙන්වුම් කරන්න පුළුවන් වෙනවා. ඒක අපි සරල උදාහරණයක් ගත්තොත් මේ තියෙන රසදිය කඳක්. එතකොට මේ අපි ගත්තොත් මේ හැම වෙලෙම වෙන්නේ මේ බාහිර වායුගෝලීය පීඩනයට සමාන වෙනවා රසදිය කන්දේ උස ධන අභ්‍යන්තර පීඩනය. So here always this external pressure equals height of this mercury level plus internal pressure. So here you can see, likewise, there is a pressure gradient because this one, if we take this one, the level of mercury, the mercury level is found as highest. It means the internal pressure of here is somewhat lower compared to this level. හරි අපි මේ බලන්න යන ඉස්සලාම බර්නෝලි කියන concept එක පොඩ්ඩක් ඉගෙන ගන්න යන්නේ. එතනදී මෙන්න මේ වගේ සැකස්මක් අපි පාවිච්චි කරමු. එතකොට මෙතන තියෙන්නේ මේකේ මේ බැරෝමීටරේ උස වැඩි කියන්නේ අභ්‍යන්තර පීඩනය අඩුයි. The height of this level is more means it has lower internal pressure. The height of this level is low means it has more internal pressure. So here likewise you can see if I take A and here if I take B, definitely, so with this barometer arrangement you can see here internal pressure is having higher here with compared to this. හැමෝටම පැහැදිලිද මෙතන අභ්‍යන්තර පීඩනය වැඩි මෙතන අභ්‍යන්තර පීඩනය අඩුයි කියන එක. Is it clear to you? So you can use පැහැදිලිද මෙතන අභ්‍යන්තර පීඩනය වැඩි ඒකයි රස දෙකේ උස අඩු මෙතන අභ්‍යන්තර පීඩනය අඩුයි ඒකයි රස දෙකේ උස වැඩි. මොකද මේ බාහිර වායුගෝලීය පීඩනයට හැම වෙලෙම රස දෙකේ උස ධන අභ්‍යන්තර පීඩනය සමාන වෙනවා. Yes, yeah. මෙහෙමයි වෙන්නේ. දැන් මේ තියෙන්නේ මේක එළියට ඇරිලානේ තියෙන්නේ. ඒ කියන්නේ මේ එළියෙන් තියෙන්නේ වායුගෝලීය පීඩනය. ඒකට වායුගෝලීය පීඩනයට සමාන වෙනවා මේ රස දිය කඳේ උස එකතු කිරීම මෙයාගේ ඇතුළේ පීඩනය. ඇතුළේ පීඩනය අඩුයි කියන්නේ රස දිය කඳේ උස වැඩි වෙන්න ඕනේ. එතකොටනේ මොකද වායුගෝලීය පීඩනය කියන එක නියතයක්. ඒක වෙනස් වෙන්නේ නැහැ. එතකොට මේක අඩු නම් අභ්‍යන්තර පීඩනය අඩු නම් අනිවාර්යෙන් රස දිය කඳේ උස වැඩි වෙන්න ඕනේ. අභ්‍යන්තර පීඩනය වැඩි නම් රස දිය කඳේ උස අඩු වෙන්න ඕනේ. අන්තිමේදී දෙන්නගේම පීඩනය එකතුව සමාන වෙන්න ඕනේ බාහිර වායුගෝලීය පීඩනය. එහෙනම් මේක ඔයගොල්ලෝ පොඩි පන්ති වල කරලා තියෙන්නේ බැරෝමීටරේ කියලා. You will have done this in grade 6 or 5. Is it clear?
It is clear, sir.
Now we know the higher pressure point is here and lower pressure point is here. So first what I'm doing is I'm going to explain you what the Bernoulli has said. Bernoulli කියපු දේ තමයි මම ඉස්සෙල්ලා පැහැදිලි කරන්නේ. Then we can apply this to a carburetor. So since and assume these red color circles as air particles. හරි. මේ රතු පාට බෝල වලින් පෙන්වුම් කරන්නේ air particles. බලමු දැන් පීඩන වෙනසක් තියෙනවානේ මෙතන පීඩනය වැඩි මෙතන පීඩනය අඩු. අපි දන්නවා වාතයේ වැඩි පීඩනය නම් අඩු පීඩනයට ගමන් කරනවා. So normally the flow happens from higher pressure point to lower pressure point. While happening this flow, see what happens at the point of Venturi. When the flow happens through the Venturi, see what happens at the point of Venturi. මේ flow එක Venturi එක හරහා යනකොට දේවල් දෙකක් බලන්න. Number 1, see what happened to the air particles. Then see what happened to the point of Venturi. What happened to the pressure of point of Venturi? හරි. එතකොට Venturi කියන තැනේ පීඩනයට මොකද වෙන්නේ කියලා බලා ගන්න. ඒකම air particles වලට මොකද වෙන්නේ කියලා බලා ගන්න. So you have to observe two things. See what would happen to the air flow. Second one, what would happen to the pressure inside the Venturi. Venturi එකේ pressure එකට මොකද වෙන්නේ? Air particles වල yes, Shari, this is a mass flow. Yes, it is a mass flow. Now you have to look after two things. See what would happen to the speed of the air particles and see what would happen to the pressure of the point of Venturi. So now the particles are moving. First see what happened to their speed and see what happened to the pressure of the point of Venturi. මම ආයෙ පාරක් පෙන්නන්නම්. දේවල් දෙකක් බලන්න ඕනේ. එයා පාටිකල්ස් වල වේගයට මොකද වෙන්නේ කියලා බලන්න. වෙන්චූරිය කියන තැන පීඩනයට මොකද වෙන්නේ කියලා බලන්න. So can anyone mention what has happened? First, what has happened to the airflow and what has happened to the pressure of the point of Venturi? Can anyone give answers for the both questions? මොකද උනේ කියලා කියන්න පුළුවන්ද? එයා පාටිකල් වලට වේගය මොකද උනේ වෙන්චූරිය හරහා ගමන් කරනකොට? එයා පාටිකල්ස් වල වේගයට මොකද වෙලා තියෙන්නේ? When they are passing the Venturi, what has happened to their velocity? අපි ඉස්සලා එයා පාටිකල්ස් ගත්තොත් ඒගොල්ලෝගේ වේගයට මොකද වෙලා තියෙන්නේ වෙන්චූරිය හරහා යනකොට? Yes, very good, Shari. The speed has been increased. And what has happened to the pressure of that point? The pressure එකට මොකද වෙලා තියෙන්නේ කියන තැන Venturi කියන තැන? Very good. Yes, it has been decreased as given by. Yes, Nathan, very good. මෙන්න මේ දෙක සිද්ධ වෙනවා. බලන්න මම ආයෙ පන්නු පෙන්නන්න. වෙන්චූරිය කරහා තරලයක් ගමන් කරනකොට තරලය වෙන්චූරිය පහු කරද්දී යාගේ වේගය වැඩි කර ගන්න ගමන්ම වෙන්චූරිය තියෙන තැන පීඩනය අඩුවීමක් සිද්ධ කරනවා. මේක තමයි බර්නෝලි කිව්වේ. So what the Bernoulli has said was, when a flow happens through a Venturi tube, at the point of Venturi, the flow increases its speed while making a decrease in pressure at the point of Venturi. Venturi කිව්වේ ඔන්න ඔය මේ Bernoulli කිව්වේ ඔන්න ඔය ටික. Venturi එකකින් තරලයක් ගමන් කරනකොට Venturi කියන තැනදී තරලයේ වේගය වැඩි කරනවා. ඒ වේගය වැඩි වෙනවත් එක්කම වේගය වැඩි වෙච්ච ඒ Venturi කියන තැන පීඩනය අඩු කරනවා. That is given by Bernoulli. Yes, yeah, it's a kind of fluid dynamic. Yes, it is correct. So now we are going to use this concept for describing the working principle of a carburetor. So we'll see that one next. And here you can see a carburetor. So this can be only seen in petrol engines because it is a unique component for petrol engine, because during the suction the system has to give air fuel mixture into the cylinder. So the carburetor is used to mix air fuel together. So here there are several things I'm going to show you here now regarding the carburetor. So here it has two major parts. The first one is Venturi tube. So this is the Venturi tube. The second part is the flow chamber. So you can see here there are two major parts in this basic carburetor. The first part is the Venturi tube. that is the one as we discussed before. Samanning diameter එක තනක අඩු වෙච්ච සාමාන්‍ය නලයක් අපි මේකට කියනවා වෙන්චූරි ටියුබ් එක කියලා. ඊපස්සේ අනිත් ප්‍රධාන කොටස තමයි float chamber එක. So normally inside the float chamber, that is the one the system uses to store fuel or to store the petrol. And if we take the float chamber, it has a connection with the fuel tank, that is the petrol intake. So it connects, the float chamber connects with the petrol tank through the petrol intake. So altogether, this carburetor has 3 main connections with other components. So the first connection here I'm mentioning is the float chamber is having connection with petrol tank through the petrol intake. That is the connection number 1. Connections තුනක් ගැන මේකේ කතා කරනවා අපි. ඒතර පළවෙනි connection එක තමයි float chamber එක petrol tankiයත් එක්ක තියෙන සම්බන්ධතාවය. එතකොට එතනදී petrol tankiයයි float chamber එකයි petrol intake එක හරහා සම්බන්ධ වෙනවා. And if we take the venturi tube, there are another 2 connections. If we take the top part of this venturi tube, that connects to the air cleaner. So venturi ඉහළ කොටස සම්බන්ධ වෙලා තියෙන්නේ air cleaner කියන කොටසට. And if we take the bottom part of this venturi, it connects to the cylinder. හරි. එතකොට venturi ඉහළ කොටස සම්බන්ධ වෙලා තියෙන්නේ air cleaner එකට. පහළ කොටස සම්බන්ධ වෙලා තියෙන්නේ engine එකේ තියෙන cylinder එකට සම්බන්ධ වෙලා තියෙනවා. Here, another important thing is that the top and bottom levels of this tube can be controlled with the help of 2 special valves. The bottom part can be controlled with the help of a choke valve or choke flap. The bottom part එක අපිට පාලනය කරන්න පුළුවන් මෙන්න මේ choke flap එක කියන එකනයි. And the lower part, or the connection in between the cylinder and the lower part of the venturi tube, can be controlled with the help of throttle valve. Another important thing, normally if we take choke, we can manually open and close that valve. With choke එක ගත්තොත් අපිට choke එක අපිට ඕන විදිහට අරින්න වහන්න පුළුවන්. And if we take the throttle valve, that can be controlled only through the accelerator. The throttle valve එක කියන කෙනා පාලනය කරන්න පුළුවන් accelerator එක හරහා පමණයි. choke එක මතක තියාගන්න අපිට ඕන විදිහට අරින්න වහන්න පුළුවන්. So I'm telling you the things again. So if we take the venturi tube, it has another 2 connection. If we take the top part, it connects with the air cleaner. If we take the bottom part, it connects with the cylinder. So altogether, I have mentioned you, there are 3 connections. First connection, the float chamber with the petrol tank through the petrol intake. And if we take the venturi tube, there are another 2 connections. Top part with the air cleaner and the bottom part with the cylinder. And another special thing is that this in this venturi tube, its top and bottom, there are 2 main valves. At the top of the tube, we can see the choke valve or choke flap that can be manually opened and closed. If we take the bottom part, there is a throttle valve that can be operated through the accelerator. So that is all about the main parts here. And there's another small important component in the float chamber, that is vent. මෙතන vent එක කියන්නේ සාමාන්‍ය සිදුරක්. So because of this vent, I think you all can see here since it is having a small hole, you can see always the internal pressure of this float chamber equals to the atmospheric pressure. මෙන්න මේ float chamber එකේ උඩ තියෙන සිදුර හින්දා මොකද වෙන්නේ? float chamber එකේ ඇතුළ පීඩනය හැම වෙලේම එළියේ තියෙන වායුගෝලීය පීඩනයට සමාන වෙනවා. So let's now see how it works. Assume that we have fully open both choke and throttle valve. And we know in the engine cycle, during the suction stroke, inside the cylinder, a vacuum is created. අපි දන්නවා engine cycle එකේදී suction stroke එකේදී piston එක පල්ලෙහාට ගමන් කරන හින්දා cylinder එක ඇතුලේ vacuum එකක් හැදෙනවා. නිකන් රික්තයක් හැදෙනවා. Yes, Shah, it is kind of a ventilator, but just a small hole. Vent means just a hole. Because of that hole, what happens is always internal pressure of the float chamber becomes equal to the atmospheric pressure. And to learn the working operation of this component, we'll see both valves are open first. It means choke valve and the throttle valves are fully open. See like that, okay? Think both valves are open now. And if we take here A and B, A means atmospheric pressure. B means pressure inside the cylinder. හරි. A කියන එක්කෙනා ගන්න බාහිර වායුගෝලීය පීඩනය. ඒතර B කියන්නේ සිලින්ඩරයේ ඇතුලේ අභ්‍යන්තර පීඩනය. During the suction stroke, we know there is a vacuum inside the cylinder. So now anyone can tell which one is higher compared to A and B. At which pressure point is much higher than the other among A and B? Which one is having higher pressure now? Yeah, yes, very good. Because A is equal to the atmospheric pressure, B equals to the internal pressure, 1 meter. So both has given the answer correctly. Both have correctly. Because A is atmospheric pressure, B equals the internal pressure, but now cylinder is in the suction, means it has a vacuum. So there's a pressure gradient. What happens now? Due to the pressure gradient, airflow happens like this. So the pressure gradient again, airflow එක ගමන් කරනවා. And now you can see there is a venturi. And you know what happens when the flow meets a venturi. So what they are doing is, now at the point of venturi, the airflow tries to increase their velocity like this. So while increasing their pressure, it results a decrease of pressure at the point of venturi. ඒගොල්ලෝ පීඩනයේ වේගය වැඩි කර ගන්නකොටම මොකද වෙන්නේ? වෙන්චූරිය කියන තැන පීඩනය අඩු වෙනවා. So now we are going to compare these two pressure points, C and D. So now anyone can tell among D and C, which one has the higher pressure? Among B and C, which one has the higher pressure? So here thing, due to the flow, definitely there will be a reduction in pressure because particles are increasing their velocity. We know according to Bernoulli, definitely there will be a reduction in pressure. And I told you, because of the vent inside the float chamber, pressure also equals to the atmospheric pressure. By considering these two, can anyone tell which one is having higher pressure among D and C? එකක් වෙන්චූරියේදී ප්‍රෙෂර් එක අඩු වෙනවා ෆ්ලෝ එක තියෙනකොට. අනිත් එක හිතන්න වෙන්ට් එක හින්දා ෆ්ලෝට් චේම්බර් එක ඇතුලේ තියෙන්නේ වායු ගෝලීය පීඩනයම තමයි. ඔය ටික හිතලා කාට හරි කියන්න පුළුවන්ද? DC බලනකොට කාගේද ප්‍රෙෂර් එක වැඩි?
D එකේ වැඩි.
කියන්න පුළුවන්ද? D ගේ C ගේ ගත්තොත් පීඩනය වැඩි කාගේද?
B.
D and C.
D.
Yes, very good. Well, Peter, so you mentioned that C, but if you can see here, because D equals to atmospheric pressure, and during the flow, we know when they are increasing the velocity, it results a decrease in pressure at the point of venturing. So, very good. So, definitely, here D has higher pressure than C. So now there's another pressure gradient from D to C, and you can see here the float chamber is filled with petrol, and now to fulfill that pressure gradient, you can see here petrol vapor now going to mix with the air particles. So now you can see now as an air fuel mixture, things are moving into the cylinder. So here you can see due to this DC pressure gradient, petrol vapor mixes with the air particles, and now as a mixture, air fuel mixture, things are moving into the cylinder. So that is how carburetor gives an air fuel mixture to the cylinder. එයා ෆුවල් මික්ස් එකක් විදිහට සිලින්ඩරයට ලබා දෙන්නේ කාබියුරේටර් මෙන්න මේ විදිහට. එක මෙතන තව එක දෙයක් වෙනවා when petrol moves continuously into this mixing chamber, definitely the petrol level inside the float chamber goes down. But here you can see there is a float needle valve, the two components named as float and needle valve. So when the flow goes down, the needle valve float also moving down, and it opens the petrol intake. Then again, petrol can come into the float chamber, which means it increases the fuel level, and because of the float, then needle valve easily can go up and close the petrol intake. So you can see it like this again. So here, see, when the petrol level goes down, the float and needle valve also move down, and it opens the petrol intake. Again, by opening the intake, again it allows petrol to come again into the float chamber. Then, since petrol is coming into the float chamber, again the float and needle valve goes up, and at a certain point, it again closes the petrol intake. It means float and needle valve here maintain a definite fuel level inside the float chamber. The float chamber එක ඇතුලේ නියත petrol ප්‍රමාණයක් පවත්වාගෙන යන්නේ float එකයි needle valve එකයි එකතු වෙලා. So that is all about the things what we had discussed under the carburetor. So then we'll discuss about our working note as well. So in this working note, I'm going to mainly consider 3 connections that the carburetor has and also its basic function. So if we take the main function of the carburetor, it is to mix air and fuel together in petrol engines. And you can see here, I told you it has 3 main connections. The first connection is with the petrol tank and the float chamber. That is through the petrol intake. And there are 2 other connections. We can see in the venturi tube. They are at the top and bottom parts of the venturi tube. If we consider the top part, there's a connection between the air cleaner. And if we consider the bottom part, there's a connection between the cylinder. And if we take this fuel system or the petrol system, it is like this. So now you can see the fuel tank. There is a fuel filter. It filters fuel. Then it gives to the fuel pump. Normally petrol vehicles have diaphragm type fuel pumps. And then it pumps fuel into the carburetor. That is the first connection. And you can see air through the air filter. Air is coming into the carburetor. Carburetor is the place where both fuel and air going to be mixed together. And then as an air-fuel mixture, you can see that mixture is given into the cylinder during the suction stroke. Suction stroke එකේදී air-fuel mixture එකක් විදියට carburetor එකෙන් cylinder එකට ලබා දෙනවා. එතන වෙනදී petrol line එකෙන් petrol carburetor එකට එනවා. Tanky ඉඳන්. That is the first connection. So if we consider the second connection, carburetor with the air filter through the venturi tube, and carburetor is to mix both air and fuel together. Then as a mixture, it comes into the cylinder during the suction stroke. So ඕක තමයි මූලිකව සිද්ධ වෙන්නේ. carburetor එකෙන් කරන්නේ air fuel දෙක එකට mix කරන දේ. So we'll go to our working note. So as I mentioned you before, so if we take grass cutters, normally they have petrol fuel system. And another thing is that if we take petrol engines or petrol vehicles, they have a unique component known as carburetor, which is for mixing air fuel together, because in the petrol engine cycle, during the suction stroke, we have to provide air fuel mixture. But in diesel engines, only air is enough during the suction stroke. But now we have to provide air fuel mixture together. So here, and carburetor is used to mix air fuel together in petrol engines. And it uses a special concept. If we consider the carburetor, it has a special concept known as Bernoulli concept. And so we are using the same concept for flying kites or flying aeroplanes. And it is like this. So you can see here, if we consider the application of Bernoulli concept when flying an aircraft, it is like this. So see, assume this as a wing of an airplane. Airplane එක wing එක ගත්තොත් මෙන්න මේ වගේ තියෙන කියලා හිතන්න. එතකොට මෙන්න මේ and it has a special kind of shape here. This wing has a special shape. Because of that shape, what happens is easily air can go through the top part of this wing. එයා wing එකේ උඩින් තමයි ලේසියෙන්ම හුලං ගමන් කරන්නේ. Since the air can easily go through the top part of this wing, more air or it easily increases the velocity. ලේසියෙන්ම යන්න පුළුවන් air particles වලට වේගෙන් ගමන් කරන්න පුළුවන් මේ top part එක පරණ. So now we know when a flow increases its velocity, at that point, it results a pressure decrease. Since because of this shape, the airflow happens at a very higher speed at the top part because they can easily move through the top. So that creates a pressure reduction with compared to the bottom of that wing, because at the bottom part, flow happens not like at the top. So now what happens is, at the top, there's a pressure reduction with compared to the top, bottom is having higher pressure. So when the යට පීඩනය වැඩි, උඩ පීඩනය අඩුයි, මොකක්ද කරන්නේ? එයා pressure gradient එකක් හැදෙනවා. ඒ හින්දා හැම වෙලේම wing එක මත උඩට බලයක් යෙදෙනවා. එන්න එහෙම යෙදුනොත් තමයි plane එකට උඩින් යන්න පුළුවන්. ඒකට plane එක ආයේ පල්ලෙහාට ගන්න ඕනම් කරන්නේ. So the plane can change its wing angular or its angle of its wings. So by adjusting that one, again, the plane can come to the ground. So here, keep that in mind. So here, you can see the bottom has higher pressure compared to the top. Yes, Yari. Kites also, if we take a kite, the concept is same because you can see, if we take a kite, if we consider the surface, it is not a flat surface. If it is flat, we can't fly it. Definitely, it should be a curvy one. අපි සරුංගලයක් කරන් බලන්න සරුංගලයක තියනවා නේද? අනිවාර්යෙන් සරුංගලයක් හදද්දී ඇන්ගල් එකක් තියෙන්න ඕනේ. පොඩි කර්ව් එකක් එක්ක හැදුවා නැත්නම් සරුංගලය යන්නේ නැහැ. අර එක්ස්පර්ට් කෙනෙක් ඕන වෙන්නේ සරුංගලයක කර්ව් එක ගන්න. ඔය කර්ව් එක හරියට ආවේ නැත්නම් සරුංගලේ උඩ යන්නේ නැහැ, කැරකිලා බිමට එනවා. So in kite also, uses the concept of Bernoulli. සරුංගලයක හොඳට පේනවා. හරියටම ඇන්ගල් එක ආවේ නැත්නම් කර්ව් එක තිබුණ නැත්නම් සරුංගලේ උඩ යන්නේ.
උකුස්සගේ wings.
Sorry?
උකුස්සගේ wings.
පෙර කුරුල්ලෙක් ගත්තත් ඒත් කුරුල්ලෙක් තුන දැන් කුරුල්ලොන්ගේ තියෙන්නේ ඒගොල්ලෝ අර දැන් අපි අර ඒගොල්ලන්ට මැනුවල්ලි ඒක හදාගන්න පුළුවන් නේද? ඒ වෙනස් කරලා තටු වෙනස් කරපුවාම වෙන්නේ අර මොහොමරි කරලා මේ concept එකම තමයි මේ ටික dynamic නේද? තටු ගහලානේ යන්නේ. ඒගොල්ලෝ උඩට ගියාට පස්සේ බර්නෝලි යන්නේ. අර කුරුල්ලගේ shape එක බලන්නකො නේද? shape කියන්නේ කුරුල්ලගේ හැඩේ තියෙන්නේ එහෙමනේ. අර ඉස්සරහට හුලං උඩට යන විදිහට තමයි කුරුල්ලා ඉන්නේ. කියන්නේ කුරුල්ලගේ ඔළුව උඩින් තමයි ගොඩක් හුලං යන විදිහට කුරුල්ලගේ shape එක හැදෙන්නේ නේද? එයා උඩට යනකන් තමයි හැබැයි අර තටු ගහනකම් වෙන concept එකක්. ගියාට පස්සේ ආයෙ පාරක් කියන්නේ බර්නෝලි concept එකයි. And then, so we discussed the carburetor has two main parts. They are venturi tube and the mini petrol tank or mini petrol storage or the float chamber. We learned that one. Chamber. And I think you all can remember we discussed three main joints. First one is with the air cleaner, that is with the top part of the venturi, and in that connection we can see the choke valve, and I told you it can be manually open and closed. And if we consider the bottom part of the venturi tube, there's a connection between the cylinder, and if we consider that connection, there's a special valve that is known as throttle valve, which can be controlled with the help of the accelerator. And there's a third connection with the petrol tank, petrol intake of the mini petrol tank or the float chamber. Here the mini petrol tank or the float chamber. So there's another connection with the float chamber and the petrol tank through the petrol intake. And I think you all can remember there was another special component, two components inside the float chamber. They are needle valve and the float. And I told you these two components are important in making definite petrol level inside the petrol tank or inside the float chamber. So that is all about what we have discussed under, the petrol fuel system. So we discussed about the Bernoulli concept, and we discussed how it could be applied for the concept of the carburetor. And we discussed some three main connections a carburetor has, and we also discussed how it works. And finally, we discussed how the things are given in a total petrol fuel system. Is it clear to you? මේටික පැහැදිලිද?
සර් ෆුට්බෝල් එක වෙන්නේ මේකද නෙමෙයි අර රගවලදී
අර සාමාන්‍යයෙන් අර
ගෝල් එක
ඉස්සරහට ඔව් ඒ දැන් අර ඒක මේකම කියන්නේ දැන් අර බෝලේ හැඩේ ගත්තොත් එහෙම මේ දැන් අපි දැන් අර ෆුට්බෝලයක් ගත්තොත් ගොඩක් වෙලාවට එයා අර පොළවෙන් නේද යන්නේ. කියන්නේ අර කකුලෙන් ඒක යන්නේ. ගොඩක් වෙලාවට බෝලේ පොළවෙම ඉන්නේ. දැන් ෆුට්බෝල් එකේ රගර් බෝලේ ගත්තොත් ඒකේ හැඩ දෙකක්නේ. දැන් රගර් ගත්තොත් එහෙම පාස් කර කර යන එකක් නේද? එතකොට හැම වෙලේම අර රගර් වල බෝලේ ෆුට්බෝලේ වෙනසට හේතු වෙන්නේ රගර් වලදී අර රගර් ඒක අර ෆ්ලෝ එකනේ හැම වෙලේම තියෙන්නේ. එයා පොළොවට උඩින් යන්නේ රගර් බෝලේ නේ හැම වෙලේම. ඒතර එයාට තව තැනකින් තව තැනකට දාන්න අර ඒ ෂේප් එක වැදගත් වෙනවානේ. දැන් ඒක රගර් ගහන්න දැන් රගර් බෝලේ ලේසියෙන් තව කෙනෙකුට උඩින් පාස් කරන්න පුළුවන්. හැබැයි ෆුට්බෝලේ අර අතින් පාස් කරන්න අමාරු වෙන්නේ කාට හරි තව කෙනෙකුට. ඒ අර දැන් රගර් බෝලේ ඔය මේ කන්සෙප්ට් එක තියෙනවා. මොකද එයාගේ ෂේප් එක ගන්න අර ඇන්ගියුලර් ෂේප් එකක් නේ තියෙන්නේ. එතකොට ලේසියෙන් අර තව කෙනෙකුට කොහොම පාස් කරන්න.
ඕවල් ෂේප් එක.
අන්නෝවල් ෂේප් එක. එතකොට අර ඒකෙන් ෆ්ලෝ එක ටක් ගාලා හැදෙනවා. හැබැයි අර ෆුට්බෝලයක් ඒකනේ දැන් අර අතකින් පාස් කරනට වඩා ෆුට්බෝලේ කකුලෙන් ගහලානේ අපි දාන්න ඕනේ. ඊට වඩා වැඩි ෆෝස් එකක් දෙන්න ඕනේ. හැබැයි රගර් බෝලේ පාස් කරන එක තමයි ඒක ෂේප් එක නිකන් බුලට් එකක් වගේ තියෙන්නේ. එතනයි බර්නෝලි කන්සෙප්ට් එක තමයි තියෙන්නේ. තේරුණාද?
Yes sir.
That is all about the carburetor and the petrol fuel system. So අපිට ඊළඟට තියෙන්නේ power transmission එක ගැන කතා කරන්න. power transmission එකට යන්න කලින් පොඩි දෙයක් කරන්න ඕන. Let's see this one first. So the next part we have to do is power transmission. So here I'm going to discuss with you about this power transmission with regard to four-wheel tractor. And here you can see how the power transmission system looks like in a four-wheel tractor. Then tractor ගත්තොත් එයාගේ power transmission එක අදනම් කරගෙන අපිට මෙන්න මේ වගේ මූලිකව යාව කොටස් තුනකට කඩන්න පුළුවන්.
සර් මේකම දර නැප්සක් දියරීසිනේදී වෙන්නේ තර ප්‍රෙෂර් එක.
නැප්සැක් එකේදී මෙහෙමයි නැප්සැක් එකේ තියෙන්නේ ඒකේ බර්න් ඕලි නෙමෙයි ඒකේ අර මේ ඇතුළට පොඩි ටියුබ් එක ඇතුළට වතුර එනවනේ. එතකොට යාව කම්ප්‍රස් කරනකොට ඒක ඉබේම ඒ කියන්නේ මේ බර්න් ඕලි නෙමෙයි ඒක තියෙන්නේ. පොඩි අර එක
ප්‍රෙෂර් එක.
ඒ කියන්නේ ඔව් ප්‍රෙෂර් එකට පොඩි එක ටැංකි දෙකක් තියෙන පොඩි ටැංකිය ලොකු ටැංකිය තියෙනවනේ. ඒ පොඩි ටැංකියට ඒකට වතුර අරගෙන ඒක නිකන් සාමාන්‍ය විදිහට ප්‍රෙස් කරලා තමයි නැප්සැක් එක ගන්න. බර්න් ඕලි නෙමෙයි. අර මේ ටැංකියට ගන්න එකේ තමයි එතන තියෙන්නේ. බර්න් ඕලි නෙමෙයි පාවිච්චි වෙන්නේ. අයි ප්‍රැක්ටිකල් එකකට දාන්න නැප්සැක් එකක් මොනවද බලන්න. එතකොට මෙන්න මෙහෙම තමයි අපි four wheel tractor එක ගත්තොත් එයාගේ power transmission system. So this is the power transmission layout of a four wheel tractor. So there you can see here, this is the engine, then gearbox, then the third part is differential unit. So you can see here three main parts. So we can divide this into three main parts. Engine is the power generation point. So we are not going to consider that one under the power transmission system. So then we can divide that into three components: clutch, gearbox, and the differential. So engine එක තමයි බලය හදන තැන. පින්ද එයාව ටිකක් අයින් කරලා power transmission system එක ගැන කතා කරද්දී මූලිකව ගන්න clutch එක තියෙනවා, gearbox එක තියෙනවා, ඊට පස්සේ differential unit එක හම්බ වෙනවා. So the three components are clutch, gearbox, and the differential. So we'll take one by one and see their main functions, okay? And how the total system transmits power with this type of layout. As the first one, we'll discuss about the clutch. Then we'll discuss about the gearbox. And finally, we'll discuss about the differential unit and the rest of the parts. Inside the gearbox, there are three main shafts. This one is known as top shaft or the clutch shaft. And then inside the gearbox, you can see there are three shafts: the top shaft or the clutch shaft, and the bottom one is known as lay shaft or the counter shaft, and on top of that there's another shaft which is known as main shaft. And here another special thing you can see here, the lay shaft or the counter shaft is extended further, and at the end it can be seen as another special one which is known as PTO in extended version, power take off lever. So the same shaft is extended as PTO as well. අපි බලමු අන්නකට PTO කියන්නේ මොකක්ද කියන එක අපි අන්තිමට බලමු. මේ counter shaft එකම එහෙම නැත්නම් lay shaft එකම තවදුරටත් වික් කරලා තියෙනවා PTO එක කියන. ඒතර main shaft එකේ ඉඳලා තමයි main shaft එකෙන් තමයි that is the shaft which brings power from gearbox into the differential. Engine එක තියෙනවා එයා බලය හදනවා. Through the clutch, power is given to the gearbox, and this is the clutch shaft, and this is the gearbox. Then through the main shaft, power can be transmitted to the differential unit. මෙතන differential එකේ බැලු බැලමටම අපිට එක මූලිකව සිද්ධ වෙන දෙයක් මෙතනින් උගරට සරලවම පේනවා. මේ කරකැවුම් බලය මෙතනට එනකන් ගියන්නේ මෙන්න මේ අක්ෂය ඔස්සේ. But after the differential, you can see that rotational power has transmitted or has changed by 90 degrees of angle. අංශක 90කින් එන කරකැවුම් බලය differential එක මගින් හරවලා it gives to the two driving wheels or two rear driving wheels. It gives that rotational power by changing its direction completely by 90 degrees of angle. අංශක 90කින් it changes the direction of rotational power and gives to the two driving wheels. So that is one main use of the differential. So we'll get one by one and see what their special functions and features. So keep that in mind. So if we take a four-wheel tractor, based on their power transmission, we can divide its total transmission layout like this. So they include three main components: clutch, gearbox, and the differential unit. So if we take the another important thing is gearbox, there are three special shafts named clutch shaft, lay shaft, and main shaft. The importance of the speciality of the lay shaft is it is extended as PTU. That shaft is further extended until it makes a special lever named power take off. And main shaft is the shaft. Main shaft is the one which transmits power from the gearbox into the differential unit. And just now we have discussed one main function of the differential is changing the direction of power transmission by 90 degrees. Otherwise, so we can operate the two rear driving. Differential එකේ දැනට නිකන් මතක තියාගන්න සිද්ධ වෙන මූලික ක්‍රියාවක් තමයි එන බලය අංශක 90කින් හරවනවා කියන දේ. ඒකට අපිට මේක තමයි දැනට නිකන් අපි මූලිකව layout එක ගැන කතා කරේ. Now the time is 11:34. So we'll start the next session by 11:45. Is it okay? Have a small break and we'll start by 11:45. Is it okay?
Is it okay, sir?
Recording stopped. Recording in progress.
So we'll start this again. And in this part, I'm going to discuss with you about the clutch, its working principle. So then we'll discuss how gears work. So then during this session, what my focus is first to discuss this one, and then we'll discuss how the gears works with some working examples. So here, first I will tell you this part, how it works, and then at the end, you have to give what is its exact function. Here, this is the one which is known as clutch. And you can see here, these are the two points it connects. It means from this side, it connects to the, there you can see the engine. And from this part, it has the gearbox. And inside the clutch, you can see there are four important parts. At the same time, their cross-sectional views are also given here. So, make important component කීපයක් තියෙනවා. ඒ important components වල මේ තියෙන මොකක්ද ඒ නංගේ හරස්කඩ කැපුමොත් එහා පැත්තෙන් පෙන්නනවා. දැන් එතකොට මේ පළවෙනියටම තියෙන engine එකේ කෙලවර තියෙන flywheel එක. So here also you can see a cross-sectional view of that part as well. Flywheel. Then the yellow color one is known as clutch plate. The orange color one known as pressure plate. And there's a special shaft or the clutch shaft or the top shaft. That is the one given here. So first we'll see the basic components. And inside the clutch there are two springs. There are few spring sets as well. So please look into them. So now we'll see how these components are working when the engine is on and when the vehicle is running, how the components are working together. So you can see when the tractor is working or when the tractor is running on a field, the things are moving like this. So if we take number one, flywheel, it is rotating because that is connected to the engine. When the engine is working means flywheel is also working. And if we take the clutch plate, clutch shaft, pressure plate. So all the shafts are moving or they are rotating. And now I'm going to highlight few things. So you can see if I take here, it means flywheel and the clutch shaft. So you can see there is no any direct contact between the flywheel and the clutch shaft. And also you can see if we take the outer surface of the clutch shaft, that is perfectly matching with the inner surface of the clutch plate. Means if someone can rotate the clutch plate, the same rotation can be given on the clutch shaft as well. හොඳට බලන්න clutch shaft එකේ වටේයි clutch plate එක ඇතුලේ එක සමාන හැඩයවල් දෙකක් තියෙනවා. එතකොට clutch plate එක ඇතුලේ තියෙන කපපල තියෙන හැඩයට 100% ගලපනවා clutch shaft එකේ තියෙන හැඩය. ඒකම flywheel එකයි clutch shaft එකයි ගත්තොත් ඒ දෙන්න අතර direct contact එකක් නැහැ. So try to get this thing only the contact between clutch shaft and the flywheel can be made only through the clutch plate. එතකොට clutch shaft එකයි flywheel එකයි අතර ප්‍රධාන කෙලින් සම්බන්ධයක් නැහැ. හැබැයි ඒ දෙන්න අතර සම්බන්ධයක් හදනව නම් හදන්න පුළුවන් වෙන්නේ අපිට clutch plate එක හරහා පමණයි. And then inside the clutch, you can see there are two springs, and the springs are in the released position. Then spring එකක් ගත්තොත් ඒ spring එකක් ඇකිලුණාට පස්සේ හැම වෙලේම බලන්නේ spring එක දිගෑරිලා ඉන්න. يعني spring එකක් ඕනම වෙලාවකදී බලන්නේ එයා දිගෑරිලා. How what we discussed in the valve mechanism. Always spring, if we take a spring, it tries to maintain its released position. So now at this moment, the springs are in the released position. Shani, it is not something elasticity, but because this is a somewhat rigid thing, no? Yes, we can take sort of an elasticity case, but here the springs are trying to always be like expanded. Right. නවලා තියාගන්න තමයි ස්ප්‍රින්ග් එකක් අමාරු. ස්ප්‍රින්ග් එක
සංකෝචන ප්‍රසාරණ.
ඔව් නිකන් ඇදිලා තියෙනවා. එයා කියන්නේ normal position එකේ ඉන්න තමයි ස්ප්‍රින්ග් එකක් කැමති. And
දුන්නක් නේද?
ඔව් දුන්නා ගන්න හරි. එතකොට දැන් අර අපි මේක කතා කරද්දී අපි layout එක ගද්දි දැක්කා engine එක තියෙනවා, clutch එක තියෙනවා, ඊට පස්සේ gearbox එක තියෙනවා. So when we are driving a vehicle, we are not driving vehicle always at the constant speed. So sometimes we have to increase the speed, and sometimes we have to increase the torque, or sometimes we have to increase the power. So likewise, we have to change the gears while we are running a vehicle. We have to change the gears. But here, when the engine is working, means always it provides rotational power to the rest of the parts. And if we need to change a gear, because inside the gearbox there are so many gears, when the things are rotating or when the things are moving, it is hard to change into a selected gear. දැන් ඇතුළේ තියෙන gears ඔක්කොම කැරකි තියෙද්දි අපිට ඕන කරන gear එකකට දාගන්න අමාරුයි, because things are moving inside the gearbox. So what we have to do is temporarily we have to stop that motion. Temporarily we have to stop that gear rotation. So what we are doing is we can just, so in case if we need to change a gear, before changing the gear, we have to stop the power transmission into the gearbox. So at that time, what we are doing is we are going to just press the clutch, and we'll see what happens when we are after pressing the clutch. So like this, this is the clutch pedal. If it is pressed, now things like this. If the clutch pedal is pressed, so you can see now the springs are compressed. Means now pressure plate doesn't provide any push on the clutch plate towards the flywheel. So now you can see only the flywheel is rotating. All other components are not rotating. Because as I mentioned you before, there was no direct contact between the flywheel and the clutch plate. Only the contact is made through the clutch plate. Now, no one is fixing clutch plate to the flywheel. Because of that, now power is not transmitted to the rest of the parts in the tractor. Right? එතකොට මේකේ පේනවා ඇති clutch pedal එක පාගපු ගමන් pressure plate එක අපි අයින් කරගන්නවා flywheel එක පැත්තේ. එතකොට මොකද වෙන්නේ? clutch plate එක flywheel එකයි pressure plate එක අතර it becomes free. So now no one is fixing the clutch plate to the flywheel. So because of that, you can see now power is not transmitted to the gearbox or to the rest of the parts. So anyone can now tell, so what is the exact function of a clutch in a tractor? Tractor එක clutch එකකින් වෙන මූලික දේ මොකක්ද එහෙනම්? So by taking these all, can anyone tell what is the exact function of a clutch in a tractor? එහෙනම් clutch එකකින් මොකක්ද සිද්ධ වෙනවා ඇත්තේ? So you can use the chat. So what is the function then done by the clutch in the tractor? Tractor එකට clutch එකක් ඕන වෙන්නේ ඇයි? Anyone? Can anyone tell what is the exact function of a clutch in a four-wheel tractor? It's an answer. Yes, I think they should disconnect engine and gearbox. Really good. I think it's a correct answer. Yes, I think Deshan, your answer is really correct. So if we take the function of a clutch, the exact function of a clutch is to disconnect the or disengage the engine. So that is given here. And if we take a clutch, it has two main positions. The earlier one was, and this one is named as engage position, because all the components are engaged with the flywheel. This position is known as engage position, and this position, the disconnected mode, is known as disengage position. In here also you can see, if we take a clutch, the main function of a clutch is to disengage the engine from the gearbox, because clutch is located in between engine and the gearbox. So then it can determine whether to transmit power to the rest of the parts or not. Especially, we need the clutch when we are changing a gear, because when we are changing a gear, we need to stop the power transmission into the gearbox. So what we are doing is we are going to just press the clutch. So then no power is given to the gearbox. So then we can easily change into the gear and then release the clutch pedal slowly, because now the flywheel is still moving. So it is it is rotating. So if we can do it, so if we do it suddenly, then the vehicle will jump. So because flywheel is still rotating.
මේ clutch එක run කරාම brake වෙනවද?
නෙමෙයි. දැන් අපි brake එක press කරද්දිත් සාමාන්‍ය brake එක පාගන කරත් clutch එකත් එක්ක තමයි පාගන්නේ. මොකද එතකොට වෙන්නේ අපි ඉස්සෙල්ලාම ගමුකෝ gear එකක් මාරු කරනවා කියලා. දැන් මූලිකවම gear එකක් මාරු කරද්දි අපි දැන් තව චුට්ටකින් කතා කරනවා gearbox එක ඇතුලේ කොහොමද තියෙන්නේ කියලා. ඒක ඇතුලේ gears ගොඩක් තියෙනවා. gear එකක් මාරු කරන්න කලින් clutch එක පෑගුවේ නැත්නම් gear එකක් මාරු කරන්න බෑ. lever එකකින් මාරු කරන්න නම් අනිවාර්යයෙන්ම gearbox එකට බලය එන එක නතර කරන්න ඕනේ. දැන් අපි උදාහරණයක් විදිහට එතකොට අනිවාර්යයෙන්ම clutch එක පා ගන්න ඕනේ gear එකක් මාරු කරන්න කලින්. එතකොට තමයි බලය ගමන් කරන එක නතර කරලා අපිට ඕන කරන gear එක දාලා වාහනේ යන්න පුළුවන්. ඒකම brake කරන වෙලාවේදී brake කරද්දී clutch එක පා ගන්න ඕනේ. මොකද එකපාර brake කරොත් වෙන්නේ දැන් මේක එකපාර brake කරොත් වෙන්නේ engine එක නතර වෙනවා. මොකද අනිත් කොටස් ටික එකපාර නතර වෙනවනේ. වාහනේ තියෙන පිටිපස්සේ කොටස් ටික රෝද ටික ඔක්කොම නතර වුණ ගමන් වෙන්නේ. මොකද එතකොට එන්ජින් එකට එන රෙසිස්ටන්ස් එක වැඩි හින්දා එන්ජින් එක ටක් ගාලා නතර වෙනවා. දැන් අපිට එන්ජින් එක නතර කරගන්න බෑනේ පාරේදී. ඒ හින්දා අපි කරන්නේ ක්ලච් එක පාගනවා. එතකොට අනිත් කොටස් ටික නැවැත්තුවා කියලා. මොකද එන්ජින් එකත් එක්ක ඒ කොටස් කනෙක්ටඩ් නැහැනේ. එහෙම නැතුව බ්‍රේක් කරොත් එන්නේ අර අනිත් ඒවා ගමන් කරන්නේ නැහැ. එන්ජින් එකට ඒවා ගමන් කරන්නේ නැතුව තියෙද්දි ගමන් කරවන්න බෑ. එතකොට වෙන්නේ එන්ජින් එක පාර නතර වෙනවා. ඒ හින්දා අපි කරන්නේ ඉස්සල්ලාම ක්ලච් එක පාගලා අනිත් කොටස් ටික එන්ජින් එකෙන් ඩිස්කනෙක්ට් කරනවා. එතකොට අපිට ඕන විදිහට බ්‍රේක් කරලා ස්ලෝ කරලා ආයෙ පාරක් ගන්න පුළුවන්. එතකොට මේ හැම වෙලෙම හැබැයි ක්ලච් එක ඔයගොල්ලෝ දන්නවා. ඔය එලවන අය දන්නවා ඉතින් ක්ලච් එක එකපාර දෙන්න බෑ. ක්ලච් එක එකපාර දුන්නොත් වාහනේ ඉස්සරහට පයින්නයි. මොකද ෆ්ලයි වීල් එක කැරකෙන ගමන් තියෙන්නේ. So if we give the rest of the parts suddenly to it, then it doesn't make any smooth power transmission. නේ. ඒතර smoothly යන්න එකපාර වාහනේ ඉස්සරහට පයින්න. But anyhow, the most important thing what you have get at the end of this part is its exact function. So keep that in mind. So we are using a gear, we are using a clutch in a tractor to disengage the engine. Only to disengage the engine, because automatically or always the system is at the engage mode. So normally clutch is in the engage mode. So what we need to do is we need to disengage. So that is the only function of the clutch, to disengage the engine from the gearbox or the rest of the parts. Is it correct? Is it clear? About
Yes,
the
sir.
clutch. So we'll put that into our working note and we'll see the rest of the things. And here you can see we are using a clutch to disengage the engine, because the clutch is in between the engine and the gearbox. So there are a few tasks, as you mentioned, while we are driving a vehicle, we need to brake, we need to slow the speeds, as well as we need to change the gears. Before slowing or before changing the gear, we have to press the clutch. While pressing the clutch, what we are doing is we are going to disengage rest of the power transmission parts from the engine. So then we can have a smooth driving. After doing the needful thing, we can again give back the power by releasing the clutch pedal. It means we are just providing back the engaged position of the clutch. So අපිට ආයෙ පාරක් අර සම්බන්ධ වෙලා තියෙන අවස්ථාවට clutch pedal එක release කරපුවම මේක පත් වෙනවා. ඊට පස්සේ so next we are going to discuss about the gearbox, and before that one, so we have to clear out what is its exact function, and by doing small calculations, we can also discuss how the gears are working together. So can anyone tell why we need a gearbox? Why a tractor needs a gearbox? කාටද කියන්න පුළුවන්ද? ඇයි අපිට gearbox එකක් ඕන කරන්නේ වාහනවලට? Or if I ask in this way, so assume that you are now driving on a highway. So when you are driving a vehicle on a highway, so what is the most needful one? Either speed or power, speed or torque. Torque means sinhala gurne. So I'm asking, what is the most needful thing? Either speed or torque, or speed or power. අපිට highway එක යනවා නම් මොකද්ද වැදගත් වෙන්නේ? Among speed and power. So what is the most needed one when we are driving a vehicle on a highway? Teshan, very good. Speed. අපි highway එක යනවා නම් අපිට ගොඩාක් ඕන වෙන්නේ වේගය. අපි යන්න බලන්නේ වේගයෙන්. And now think, now we are driving a vehicle on a mountain. So now we are climbing a mountain through the vehicle. So now what is the most needed one? Either speed or power. අන්දක් නැගිනකොට ස්පීඩ් එකද බලයද වැඩින්න වෙන්නේ? What is the most needed one when you are driving a vehicle on a mountain? Yes, 0321. Yes, it's very good. It is power. So likewise, you can see. How to do it? So likewise, you can see when we are driving a vehicle, according to the situation, in some cases we need speed and some cases we need power. So likewise, based on the need, adjusting speed and power into the required level is done by the gearbox. That is one of its main tasks. So if we take a gearbox, that is the one which adjusts power and speed according to the given driving condition. So gearbox එකෙන් තමයි ඕන කරන driving condition එකට අදාළව වේගයයි බලයයි සකස් කරලා දෙන මූලික ඒක. So it adjusts speed and power according to the required driving condition. According to the given driving condition, it adjusts the required speed and power. So that is the one main task for gearbox. Other than that, can anyone tell? There's another main task by a gearbox. Can anyone mention that one? So, වේගයයි බලයයි සකස් කරලා දෙන එක. අදාළ කරන එළවුම් අවස්ථාවට අනුකූලව වේගය සහ බලය සකස් කර දීම තමයි gearbox එකෙන් සිද්ධ වෙන්නේ. ඕක තමයි ප්‍රධානම දේ. ඕකට අමතරව තව එක ප්‍රධාන කාර්යයක් සිද්ධ වෙනවා. So I am asking that one. Can anyone tell or can anyone put that into the chat? What is another main use of a gearbox? So first one is obvious. So adjusting speed and power according to the given driving condition. That is the main function. There's another main function I am asking that. Gearbox එකකින් වෙන තව වැඩක් තියෙනවා මොකක්ද? You may all know that. Everyone has experience in a vehicle, either in a bus. මොකක්ද ඊළඟ වේ? gearbox එකක් පාවිච්චි කරලා වාහනයකින් කරන තව දෙයක් තියෙනවා. You know it. කාටද කියන්න පුළුවන්ද? වේගයයි බලයයි සකස් කරනට වඩා gearbox එකෙන් කරන තව වැඩක් තියෙනවා වාහනවල. The main task. කාටද කියන්න පුළුවන් චුට්ටක් හිතලා? අනේක it is another kind of driving mode. Can anyone tell it? කාටද කියන්න පුළුවන්ද? Very good. Nishant has given the correct answer. Journey reduction of resistance. That is again much allowed to the task that I have already told. Okay, changing torque and power, torque and speed like that. But so another thing, as Deshan mentioned, another important thing is changing the driving direction, because vehicles are not always moving towards the forward way. In some cases, we have to move them reverse as well. So another most important function by the gearbox is changing the driving direction. So if we take a gearbox, it has two main functions. The first one is adjusting speed and torque according to the existing driving condition. That is the number one, adjusting speed and torque. And if we consider the number two, the task number two is changing driving direction. So let's now see how the gearbox, how it can do these things. So for that one, what I'm going to do with you is, so we'll do some simple calculations. We'll do set of simple calculations, and then you will see how the gearbox is capable in doing these two tasks. අපි පොඩි ගණන් කීපයක් හදමු gearbox එකක් මේ දේවල් ටික කරන්නේ කොහොමද කියලා. ඒ කියන්නේ gears එකතු වෙලා මේ වැඩේ කරන්නේ කොහොමද කියලා බලමු. එතකොට ඔයගොල්ලන්ට අන්තිමට පුළුවන් gearbox එකකින් වෙන ෆන්ක්ෂන් එක කොහොමද සිද්ධ වෙන්නේ කියලා හරියටම බලා ගන්න. So we'll do some small calculations and see how the gearbox is capable in doing these two functions. Right? මේ ගණන් ටික ඔයගොල්ලොත් මාත් එක්ක හදලා නම් මුලින්ම ලේසියෙන්ම බලා ගන්න පුළුවන් කියන්නේ. gearbox එකෙන් මේවා වෙන හැටි අපිට ලේසියෙන් බලා ගන්න. වෙලාවක් ඉන්නේ. ගාන ගන්න පුළුවන්. උන්දී වෙලාවක් දෙන්න. So you also can join with this one when we are doing these calculations. Assume I'm going to consider two systems here, two gears, one is bigger and one is smaller, A and C. Here assume this A is the driving gear and C is the driven one. 11 A, 11 C. But in the next figure, you can see there are 3 gear wheels. Other than A and C, there's a new one named B. So we'll do some small calculations. So here always A is the input gear and C is the output gear. A means which is the one taking power into the system, and C is the one which is taking out, which is taking power out. So here, here you can see their number of gear teeth is given here. So if we take A gear, number of teeth it has is 32, and if we take C, number of gear teeth that it has is 16. So by using their number of gear teeth and knowing the speed of one gear, we can find the speed of the other gear. So here, shall we do the first part of the question? And you can see if the number of gear teeth of gear A is 32 and C is 16. And assume that if the speed of gear A is 1000 rounds per minute. And think now we have to find out the speed of gear C. So for doing this one, so you can use this equation. Give me a second. So you can use this equation. So the way of writing this one is like this. So here, if we need to find out the speed of this C gear, first write it here, speed of gear C. And then another thing you have to do is divided by, then at the speed of the gear, what you know? Speed of gear A. And then, so we are going to find out this one by using their number of gear teeth. So then write it like this. So here in upside down way, you have to write it. So in the next part, at the first half, write the number of gear teeth of the one you given in the first part at the below part. අපිට ඕනේ C ගේ වේගය බලා ගන්නනේ. ඒතර speed of C කියලා ලියලා බෙදීම speed of A that is given 1000 rpm. ඒතර මේක අනිත් පැත්තට මේ equation එකේම දාන්න ඕනේ. උඩට දාන්න දැටි ගාන කාගේද මේ කලින් පැත්තේ යට ඉන්න කෙනාගේ. So here write the number of teeth of A as the top one, then divided by number of teeth of C. So can you find out what should be the value by putting the things like this? මෙහෙම දාලා අගේ හොයාගන්න පුළුවන්ද? Because we tell normally speed of gears and their number of gear teeth, there is a inverse proportion. ඒක කියන ප්‍රතිලෝම සමානුපාත භාවයක් තමයි තියෙන්නේ. දැටි ගානයි වේගයයි අතර. There's an inverse proportionate between number of gears and the gear speed. So we can write it like this. Speed is the one we needed. So write it at the top, then divide the speed by the other gear. So when we are writing the other part, take the one you put at the bottom in the previous part, now at the first. In terms of their number of gear teeth. And then put the bottom part, the one what you put at the top one in the previous part. කාටරි හොයලා කියන්න පුළුවන්ද? So then you can write the things like this: speed of GRC, that is the one we need to find out, and we know the speed of GRC, that is 1000, and the opposite thing. A has 32 number of GRT, C has 16 number of GRT. Can anyone tell what is the answer for that? කාටරි කියන්න පුළුවන් උත්තරේ කීයද කියලා? මේක සුළු කරලා හදලා කියනද කියලා උත්තරේ කියලා?
2000.
Yes, very good. Yes, I think Shehan. Charlie, Yvonne, none among them. So you all have given the correct answer. That is 2000. Very good. So we'll put that here. 2000. This also now. So you all have given the correct answer. Very good. And then so we'll do the same for here now. Here, when we are applying this equation, we can only apply the equation for the near gear wheels only. So it means now if we need to find out the speed of GRC, we can't do it directly. We have to go through like this. First, we have to find out the speed of B. Then we have to find out the speed of C. So we'll first find out the speed of B. So I will show you a way of finding it. So you have to do the calculations. You will need. So here we know the speed of gear A, that is 1000. We know the number of gear teeth, it has 32. But we don't know the speed of gear B, that is the one we have to find out. But we know the number of gear teeth the gear B has. So by considering this all, we can put the equation like this. So she has also given the correct answer for the previous question. So now we need to find out the speed of gear B here. And so write in the first part of the equation, write it as first. Then write the speed of the gear wheel, you know. Speed of gear A. And then the other part, it means in the number of gear teeth part, write the things upside down. So earlier A was below here. Now in terms of gear teeth, take it to the top. Gear of A and divided by gear of B. So you can put like this now. So now can anyone tell what is the answer for this one? Very good. I think usually I think I have mentioned her name correctly. 03022. And here you can see the answer is correct. Yes. Yeah. Yes, the answer is correct. So now we know the speed of GMB as well. And who has given the answer correctly? Very good. And now, can you find out the speed of GRC? Because now we know the speed of GMB. So what I'm asking you to do now, find out speed of GRC. Right. Then අපි B වෙනකම් කරා කාට හරි පුළුවන් C වලත් හොයන්න. දැන් අපි B වල දන්නවා. Using the same equation, we can find the answer for GRC. අපිට අන්තිමට ඕනේ C ගේ ස්පීඩ් එක කීයද කියලා තමයි බලාගන්න ඕනේ. So for that one, we'll do this way. I have given the answer, but I think it has to be rechecked. So we'll do this in this way. So we'll use the same concept here as well. Now we need to find out the speed of GRC. Put it as top, then the lower one is the one known, and change it upside down in terms of their number of gear teeth. Put B first, and the bottom part put the width of C. And here you can write it like this. Because earlier we didn't get an exact answer because there's some decimal points. So for that, we can write it like this here. අර කලින් කියේදී මේ හරියටම එකක් ආවෙ නැති හින්දා අපිට මේක මේ වගේ ලියන්න ඕනේ. ඒ කියන්නේ අරකම තමයි. හැබැයි අර බෙදෙන්නේ නැති විදිහටම ගන්න. එතකොට ලේසියෙන් වෙනවා. අර කලින් ආපු උත්තරේ බෙදෙන්නේ නැති විදිහට ගත්තොත් මෙන්න මේ වගේ තමයි එන්නේ. අපි කලින් එකේ ස්පීඩ් එක හැවුවේ 32 බෙදීම් 24 නේද? ඒ වගේම ගමු. So I think most of you have given the correct answer, that is 2000. Shahari 021 022 Keshwani. So then the answer should be 2000. So here you can see even though it has somewhat different arrangement, but you can see finally the value is same. And we'll do the same for the torque as well. Okay. So if we take speed and number of gear teeth, it has inverse proportionate. So they are inversely proportionate together. So that's why we have put one part as upside down. මේ දෙක අතර තියෙන ප්‍රතිලෝම සමානුපාත භාවයක් ඒකයි අපි උඩයට මාරු කරලා මේකේ දැන් අපි බලමු ඊළඟට මේකේ torque එක හොයන්න. So the next part is torque. So we'll see how to do that one. When we are finding out the torque, we have to do it like this. Well, then we'll take the first one. මේකේ බලන්න. So here the torque of gear A is given, that is 100 Newton meter. ගූර්ණය කියලා කියන්නේ ඒකයි. gear A කෙනාගේ ගූර්ණය දීලා තියෙනවා Newton meter CI. And they have to find out the torque of gear C. අපිට දැන් හොයන්න ඕන කරන්නේ C ගේ torque එක. So for that one, now see how we can write the equation. So the torque of C is the one we needed to find. So we have to divide it by the one that we know, that is torque of A. So, but if we consider here, normally the torque and number of gear teeth has a direct proportionate. So they are directly proportionate together. අනුලෝමව සමානුපාතික වෙනවා. يعني එකක් වැඩි වෙනකොට අනිකත් වැඩි වෙනවා. So here, when we are finding out the torque by using number of teeth, we have to put them like this. It means the same side. Even in the next part, we also have to give them like this. The top part also same as the previous one. Even though it was number of gear teeth, the format is same for both sides. I think one has given the answer. Shehwari, 500. We'll check that. So, can you do this and give the answer? I think maybe 500. Is it 500? No. So, can you please check the answer? Yes, it should be 550. No. Very good. Vinayaka with the 03-222. Very good. I think the answer should be 50. About the it should be 50. So we put that here 50. It's very good. 0321. So we will have get the answer very correctly. And here, so now in the second system, so if we need to find out the torque of C as what we did for speed, we have to pass out the same routine. So we can't add the equation just to A and C if it is like this. But earlier there was only 2, then it was okay to directly apply the equation. But now we can't apply it directly. We have to go through first AB, then BC. So can you find out what is the torque of B with this setting? So we'll do that one as well. Hero has given the answer. It is correct. So what you have to do now is use the same format in the both sides. Torque of B is the one we need to know, divided by torque of A. We'll check the answer. The Mini has given this very good. I think Abhinayaka found the 03022 Shulani. Yes, who has given the correct answer? We will put that here. 75. And now I think you all can easily find out the final one. What is the torque of the 21? Your answer is also correct. So now can you find out that what is the torque of C? So we'll do that one as well. So the same format you can use and find out the torque of C. So we'll do the same way. Torque of C divided by torque of B, same pattern for the other part as well. So then you can put the things like this. Torque of C. So we know the torque of B was 75. And just dividing the number of teeth as in the same format. So now can you give the what is the answer? I think yes, yes, given the correct answer. Shunan 50, Abhinay 3021. I think your answers are correct. Should be 50. And Hilmi, yes, the answer should be 50. So you can see here. But the most important thing is, so if at the end you can see, even though this system has, so even with the new gear wheel node B, the final speed of this system is also same as the previous. If we take the torque, that is also equal as the previous one. but there is a change. So can anyone point out what is the difference? There is an exact difference here in between these two systems given in figure 1.1 and figure 1.2. But numerically, all the values are same. But there is a change. There is a difference. So can anyone point out what is that difference? මෙතන බැලුව බැලමටම අගයන් ටික ඔක්කොම එක වගේ. මේ මෙතන එකම එක වෙනසක් තියෙනවා. කාට හරි පුළුවන්ද කියන්න what is that difference? What we can see. So it is not clearly given, but there is a difference. Can anyone point out that difference? Numerically, all the values are same. හැබැයි values ටික ඔක්කොම එකම ගණන් ලැබිලා තියෙනවා. හැබැයි එකම එක වෙනසක් තියෙනවා. කාට හරි කියන්න පුළුවන්ද මොකක්ද ඒ වෙනස?
This one has a B. This one also has a C.
Can anyone tell what is the difference between these two systems? So can you figure out it in terms of their rotational directions? In both systems, the rotation of A is clockwise. That is given as clockwise rotation. So can you figure out any difference in output gear in these two systems? But the values are same. Their torque and speeds are same. I am asking, can you point out the main difference between these two systems?
This one has a C.
So I can give a small hint that is based on their driving direction.
Also B. C.
පුළුවන් ද කියන්න මොකක්ද කියලා? Can anyone try? So normally here, this has clockwise direction. So the direction of rotation of C is anti-clockwise. GS දෙකක් ගත්තොත් මෙයා කොහෙටද කරකින්නේ? ඒ ඔරලෝසේ කටු කරගෙන පැත්තට කරකිනවා නම් GR එක අනිත් GR එක කරකින්න ඕනේ ඒකට ප්‍රතිවිරුද්ධ දිශාවට. So that is given as anti-clock.
Where can you?
But here, if we take this one, the gear B has anti-clockwise motion, but again, the gear C has the clockwise motion. Is it correct? Is it clear to you? So I think 021, I think should have given the correct answer. So only, so here you can see the two systems are equal in their final speeds and the torques. But the only difference what you can find here is their driving direction. So you can see that difference is made here with the help of this B gear, and that B gear is known as here as idle gear. Because it doesn't make any difference in numerically, but it is, even though it is not making any difference numerically, but it makes a significant change. That is only changing the driving direction. So you can see in a gear system, if there's a third gear comes, it definitely only changes the direction of rotation, not changing either speed or torque. දැන් මේකෙන් පැහැදිලිව පේනවා ඇති gears දෙකක් තියෙනකොට තුන්වෙනි gear එකක් ආපු ගමන් කරන්නේ එයා gear එකේ අවසාන වේගය හරි ගෝර්ණය හරි වෙනසක් කරන්නේ කරන එකම දේ එයා කරගෙන දිශාව වෙනස් කිරීම පමණයි. So here this B gear is known as idle gear. That is much important when we are discussing how the gearbox makes the reverse motion. So these are the basic things what you can what we can get from here. So basically we have made two relationships. One is with the number of gear teeth and the gear speed, that is inversely proportionate together. And another thing was number of gear teeth and torque, they are directly proportionate together. So we'll add this thing to our working note first. So here the function of a gearbox is to change the speed and torque according to the given driving condition. Example is when climbing a mountain, we need power, either torque, and when driving on a highway, we need speed. So that is the basic example we can take. And the next most important function by the gearbox is to change the driving direction. So we can make this type of relationship. So torque and number of gear teeth. So we put the same format at the top as well as the bottom, because they are directly proportionate together. If we take number of gear teeth and speed, then we have to make it upside down at the second part of the equation. So here number of gear teeth of A divided by C means we are writing it in terms of speed. We have to write it upside down because number of gear teeth and speed are inversely proportionate together. දැටි ගානයි වේගයයි ප්‍රතිලෝමවයි සමානුපාත වෙන්නේ. And so now we'll see how this gearbox works. And for that one, I am going to use this. Give me a minute. Here I'm going to show you the way of gearbox, how a gearbox works. And as I mentioned you before, it has three main gear shafts. top shaft is the one which takes power into the gearbox, and there is a counter shaft, then the main shaft. So main shaft, the specialty of the main shaft, it is the one which only contains movable gears, and that is the one connects to the gear lever as well. So when we are making the gear lever, we are changing the levers, the gears are selected as given here. So in the first part, it shows you how the first gear happens. So if the things are like this, we tell the gearbox is in the first gear. So you can see a big larger wheel connects with the C1 gear of the counter shaft or the lay shaft. And then if we put into the second gear, then things like this. So so earlier you can see the connection was with M1 and C1. But now you can see now the connection is with M2 and C2. So definitely you can see their sizes are somewhat different. Because if we consider M1 and M2, M1 is bigger in size. So normally gear 1 has higher torque. So higher size because if number of gear teeth increasing means torque is also increasing. And if we take third gear, you can see both top and main shafts are connected together. So it means it gives the exact speed of the top shaft. And in case of reverse gear, you can see now the things like this. This is the top shaft, the counter shaft or the lay shaft, and then the main shaft. In between M1 and the reverse gear, now you can see there is an idle wheel. So we know if there is an idle wheel, what it does is it never changes either torque or speed, but it only changes the direction of driving or the direction of rotation. So we'll see this in a video as well. It shows you how the gears are selected. So we'll see that one as well. මේකත් බලමු පොඩ්ඩක්. බලමු පොඩි වීඩියෝ එකක් තියෙනවා ඒකත් බලමු. And here, this type of gearbox is known as sliding mesh gearbox. So you can see how the gearbox works. So now, in the neutral position, uh, again, no power is transmitted to the rest of the parts. So you can see when it is at the neutral position, no GA is involved in power transmission. So we'll see how it works when gear first. So you can see a bit larger wheel is fixed with another big wheel of the lay shaft. So that is how it works, the gear 1. And when gear number 2, you can see the arrangement is like this. The next gear connects with this. So only the gears of the main shafts are connecting like this. And this is how it works in gear number 3. So you can see both top shaft and main shafts are now connected together. That is how it works, gear number 3. And now you can see how it works under the reverse gear. So now you can see there's an idle gear wheel which changes now the rotational direction. I will show you it again. So this is a sliding, this gearbox is known as sliding mesh because after a slide, it measures with the gear. That is why it is known as sliding mesh. So now you can see how it works during neutral. No gear is involved with another gear for power transmission. And now see how it works under the gear number 1. And also see only the gears in the main shafts are movable. So they are the one connects with the gears of the counter shaft. And in the gear number 2, you can see now the connection has changed. And in the gear number 3, both top and main shafts are connected together. And in the reverse gear, what happens is the main shaft, the gear of a main shaft connects through an idle wheel to a gear at the lay shaft. So we know if there's an idle wheel, what it does is it only changes the driving direction. So we'll come back to our working note again. So here, so this is the basic relationship what we have discussed earlier. And we take here, and we know if there's an idle gear, only the function of that gear wheel is changing the direction of rotation only. And here, so if we take a sliding mesh type gearbox, it contains this type of gears. So these types of gears are known as spur gears because exact edges they are having. මේ වගේ එකට අපි කියනවා spur gear එකක් කියලා. Normally a sliding mesh type. So what the gearbox what we have discussed here named as a sliding mesh gearbox, and a sliding mesh gearbox usually contains spur gears, means this type of gears having a rigid edges. I think at the end you should know the way how the gearbox changes its gears. And when changing gears, so it changes the gears for doing two main things. The first one is to change the driving speed and torque according to the given driving condition. That is the number 1 thing. And the number 2 thing is to change the driving direction. That is done with the help of an idle gear wheel. I think they are correct. Are they clear to you? I think we can complete this session as well. How about it? Is it clear to you? The basic function by the gearbox? Is it clear? Clutch එක gearbox එකේ කරන කාර්ය ටික පැහැදිලිද? This session mentioned is correct. Is it okay? So if it is okay, we have another only one session. So we'll start it by having our lunch break. Now the time is 1:70. Shall we start by 1:45 having the lunch break? Is it okay? Have a question again? Lunch break එක අරගෙන ගමද? ටිකක් ඒක නැත්නම් කලාවේ. break එකට යන්න මොකද කියන්නේ?
Okay, sir.
So we'll have a 30 minutes break. So we'll start by 1:45.
1:45.
Recording stopped.
So we'll start the final session. So we have, with regard to power transmission system, we have completed the touch gearbox, and now we have to discuss about the differential. And after the differential, we have only one component, that is final driver. So we can finish the power transmission then. So here, as I mentioned you before, so when the vehicle is on a straight drive, what the differential does is it splits power at 90 degrees of angle, but it comes to the differential, it transfer at 90 degrees of angle and gives to the rear driving wheel through the final drive. So these two axles are known as rear axles. So find if this is the differential, so then it has two rear axles and it transmits power to the rear driving wheel through the final drive. So on straight driving, කෙලින් වාහනේ ධාවනය කරනකොට ඩිෆරන්ෂල් එකකින් කරන්නේ එයාට ලැබෙන බලය සමාන කොටස් දෙකකට කඩලා ඒ බලය පසුපස එළවුම් ප්‍රෝධ දෙකට ලබා දෙනවා. ඒතර මෙතනදී විශේෂත්වය ඉන්නේ මේ බලය අංශක 90 හැරවිලා තමයි එහෙම දෙකට බෙදලා දෙන්නේ. So there are two things happen. One is dividing power into two equal parts and give them to the driving wheels by rotating it, or by converting it at 90 degrees of angle. අංශක 90කින් කරකවල තමයි එළවුම් රෝධ දෙකට ලබා දෙන්නේ ඒ කෙලින් යන අවස්ථාවක. So we'll see how things happen when tractor is on a bend. When the tractor is driven on a bend. හරි. අපි දැන් බලමු tractor එක වංගුව කරගන්නකොට මේකේ මොකද වෙන්නේ කියලා. So for that I just using the small video clip for you. So we'll see how vehicles are taking bends. So how the vehicles are driven on bends. අපි දැන් ගත්තොත් so මේ here you can see 5 bikes together. Here don't take it as bikes, just take it as a vehicle just having the 2 wheels. So forget about as bikes, just consider it as a vehicle. So there will be 2 rear driving wheels. And see what happens when the vehicle takes a bend. Make a bike park කියලා හිතන්න එපා. හිතනකො මේක එක වාහනයක් කියලා. එතකොට wheels දෙකක් තියෙනවා. The wheels, there's a wheel outside the bend and there's a wheel inside the bend. This is the wheel inside the bend and this is the wheel outside the bend. Think like that. හිතනකො වාහනයක් මේක. එතකොට වංගුවේ පිටපැත්තේ රෝදේ වංගුවෙන් ඇතුළු පැත්තේ රෝදෙකුයි තියෙනවා කියලා හිතන්න. වංගුව ගද්දි මෙන්න මෙහෙම දෙයක් වෙනවා. So you can see always outer wheel rotates longer distance than the inner wheel. It means outer wheel has to rotate much faster speed than the inner wheel. So I'm again showing you that. So you can see outer wheel has to rotate much faster speed than the inner wheel. Then only the vehicle can take the bend. පිට රෝදෙට ලොකු දුර ප්‍රමාණයක් වැඩි වාර ප්‍රමාණයක් කරකෙන්න ඕනේ ඇතුළ රෝදෙට සාපේක්ෂව. එහෙම වුණොත් විතරයි වාහනයට වංගුවක් ගන්න පුළුවන් වෙන්නේ. So here again I am showing you වංගුවෙන් පිට රෝදෙට වැඩි වේගෙන් කරකෙන්න ඕනේ ඇතුළ රෝදෙට සාපේක්ෂව. එහෙම වුණොත් විතරයි වාහනයට වංගුවක් ගන්න පුළුවන් වෙන්නේ. So that is done by the differential. So again, I will show you another video. So here you can see, here now through the vehicle it is taking the bend, and then by only rotating the outer and inner wheels, the same thing can be done. Here to represent the powerful one, a man is rotating this wheel, and to show the lower power, a woman is rotating another wheel. So you can see always along the side where the woman we can see the vehicle takes the bend, and this is the one outside wheel. So you can see outside wheel, and you can see අඩු වේගෙන් යන්නේ වංගුව ඇතුළේ වීල් එක, වැඩි වේගෙන් ගමන් කරන්නේ වංගුවේ පිට වීල් එක. ඒතර පේනතර වැඩි වේගෙන් කරකන එක තමයි outside wheel, අඩුවෙන් යන එක නා inside wheel. මෙතන ඒක හරියම ක්ලියර් වට පේනවා. මේ තියෙන්නේ inside wheel, මේ තියෙන්නේ outside. outside එක කෙනා තමයි වැඩි වේගෙන් යන්නේ, inside එක කෙනා හරියම අඩු වේගයකින් ගමන් කරන්නේ. So this is done by the differential. So at the end you can see here the differential has 2 main functions. So one function is on the straight driving, it divides the power coming into it into 2 halves and providing that power by transmitting at 90 degrees angle into the 2 rear driving wheels. ලැබෙන බලය හරියටම අංශක 90කින් හරවලා කොටස් දෙකකට බෙදලා එළවුම් රෝද දෙකට ලබා දෙනවා. ඒකම තව දෙයක් තමයි with the help of differential only, tractors can be driven along the bends. So you can see here the differential has 2 important tasks. So the first one is to drive tractors along the bends. වංගුවල ධාවනය කිරීමට මේක අත්‍යවශ්‍යම කොටසක්. ඒකම කෙලින් ධාවනය කරද්දී differential එක තමයි ලැබෙන බලය සමාන කොටස් දෙකකට කඩලා අංශක 90කින් හරවලා එළවුම් රෝද දෙකට ලබා දෙනවා. So that is the function by the differential. So is it okay? Is it clear to you the function of the differential? Differential එකේ function එක ගැටලුවක් නැහැ නේද? Is it okay? So if it is okay, please put yes. Okay. And 301, 302. And now we are going to discuss about the final part, that is the final drive. So here the rest of the part after the differential lights, it looks like this. As I mentioned you before, the differential. Then there are two rear axles. They are going to be joined with the rear driving wheel, the big wheel, through the final drive. And the connection like this. So here, the yellow color one, which is known as the differential. Here you can see it. The car part is the differential. The ratu part is the rear axles. Here that is given here. So this rear axle doesn't directly connect to the rear wheel. The rear axle එක කවදාවත් කෙලින්ම පසුපස එළවුම් රෝදයට කෙලින්ම සම්බන්ධ වෙන්නේ. So you can see it connects to the rear driving wheel through a gear set. You can see it directly connects to the small gear wheel that is given in pink color, and that gear wheel operates a bigger wheel which is given in blue color, and at the center of that blue color gear wheel, there you can see an axle, an axle which connects to the final driving wheel, final rear driving wheel. I පාරක් ගත්තොත් මේ කහ පාට කොටසෙන් කියන්නේ differential එක. මේ රතු පාටකින් කියලා කියන්නේ rear axle. මේ rear axle එක මේ ඇතුලේ තියෙන හැටි පේනවා. rear axle එක ඉස්සල්ලාම සම්බන්ධ වෙනවා පොඩි wheel එකකට. ඒ පොඩි wheel එක සම්බන්ධ වෙනවා ලොකු wheel එකට. ලොකු wheel එකේ තමයි පසුපස එළවුම් රෝදේ සම්බන්ධ වෙන අක්ෂය තියෙන්නේ. So with this arrangement you can see, so a bigger wheel is rotated by a smaller wheel. So definitely you know when a bigger wheel is rotated by a smaller wheel means, so we have discussed the equations. When the size is bigger means torque is more because number of gear teeth are directly proportionate to the torque given by that gear wheel. අපි දන්නවා අනුලෝමව තමයි සමානුපාතක වෙන්නේ. What is the differential එකට කියන්නේ මතක් වෙන්නේ මම මතක් කියලා අත එන්නේ ඔබට final drive එකට නම් කියන්නේ නිමි එළවුම කියලා. differential එකට කියන්නේ විවිධ කරන දේ කියලා මම බලන්න කියන්නේ. Here අපි දන්නවා දැන් පැති ගාන ටෝක් එකට අනුලෝමව සමානුපාත වෙනවා. එතකොට රෝදේ ලොකු වෙන්න ටෝක් එක ලැබෙනවා වෙන්නේ. So normally tractors are known as field vehicles. So here the finally what tractor needs more is torque than the speed, because we are using tractors to do more work. Then so we don't need much speed. Actually we need torque. So here so these two gear wheels collecting together known as final drive. Here this tractor uses a final drive to further increase the torque of final driving wheels. But final drive එක පාවිච්චි කරන ට්‍රැක්ටරේ විසින් අවසානයේ එළවුම් රෝදේ මගින් දෙන ලබන ටෝක් එක තවදුරටත් වැඩි කරගන්න. So here the final drive, that is to further increase the torque or power of the rear driving wheel. So with that one we can complete the power transmission system. So we have discussed new two components, differential. So on straight drive, it is used to divide power coming into the differential into two halves and give them by turning 90 degrees angles into the rear driving wheels. And along a bend, to drive along a bend, also we need and also on a bend to drive the vehicle, we need differential. And finally, we need the final drive to further increase the final torque of the rear driving wheel. Antara avakalan. I will check it, okay? I'm not quite sure about the name. I will check it. Antare, yes. Differential means Antare කියලා ඔක තියෙන තමකන් ටයික නමක් තියෙනවා. මම බලලා කියතේ. So here, then in the system, so you can see at the end, there is a power. Usually, this lay shaft extends until the tractor, at the end of the tractor, with a special name that is power take off. So, we'll in the next part, the last part, we are discussing about land preparation implements. There we can discuss about this PQ as well. So that is all about the basic things under the tractor. And as the last part, we are discussing about the land preparation implements. Okay. So in the same session, I'm going to discuss that one as well. So next we'll discuss about the land preparation implements. So screen showing that So in this video, I will show you about the PTO, how it works. So let's see it. So we are using tractor PTO to take some rotational power out. කැරකෙවුම් බලයක් ට්‍රැක්ටරෙන් එළියට ලබා ගන්න රෝදයට අමතරව තවත් කැරකෙවුම් බලයක් ලබා ගන්න ස්ථානයක් තමයි ට්‍රැක්ටර් PTO එක කියලා කියන්නේ. ඉතින් බලමු ට්‍රැක්ටර් PTO එක මොනවා ගැනද කියලා. මෙතන පේනවා ඉතින් මේ තියෙන්නේ ට්‍රැක්ටර් PTO එකක් පාවිච්චි කරලා කම්පෝස්ට් ස්ප්‍රෙඩර් එකක් පාවිච්චි කරන හැටි. So they are operating a compost spreader using this tractor PT. And here, and I will show you what is tractor PTO. Here. And here you can see, this is the one known as power take off or tractor PTO, power take off. So it is an extension of the lay shaft or the counter shaft. So it is further extended until at the end of the tractor, and at the end of the tractor it is named as power take off shaft. So you can see here, that is at the end of the tractor, we can see it. And here you can see the exact view of the tractor PTO. And now in here, the trailer part of this tractor needs rotational power, or this compost spreader needs rotational power, and that power is taken, that rotational power is taken with the help of this tractor PTO. So you can see that there, I'm pointing out the cursor is the point known as tractor PTO. So you can see now it is fixed with this special shaft. So you can see clearly, this is the tractor PTO. Show you again. So clearly you can see the tractor PTO, this is the tractor PTO, and the shaft is inserted. Now the rotational power can be transmitted to the latter part of the trailer. So there can see the spreader. So now with the help of this arrangement, the tractor can spread compost on the ground. කරන්නේ කැරකෙනකොට rotational power එක tail එකට දෙනවා. tail එකෙන් පුළුවන් වෙනවා එතකොට අර blade set එක කරකවලා, so now the tail can spread compost on the ground. It's a tractor PTO, so you can see now the system is removed, and this is how it works. So you can see by taking rotational power, the blade set is operated and compost are spread on the ground. There's another video. If you take this video, it is just an anime. It's a toy tractor, but the concept is even though it is a toy, the concept is same as an actual one. So here you can see this toy tractor operates a engine-driven type water pump. Because engine-driven type water pump means it also needs some rotational power to pump water. Here you can see how the PTO gives that rotational power for operating that toy water pump. So see it. So So this is the engine driven water pump. So you can see by taking rotational power. So now you can see it pumps water to the ground. And another thing, so it takes rotational power from the tractor, and for any type of implement to connect it with the four-wheel tractor, this type of connection is needed, and that connection is known as, for connecting with the tractor, this type of links are needed. So these links are known as 3-point linkage. So any implement can be connected to the tractor with the help of the 3-point linkage, because it has 3 linkages. That is why it is named as 3-point linkage. In another video, I will clearly show you how the 3 points of that linkage works. And this shows you how that water pump is made. Even though it is a toy, the concept is exactly similar with an actual one. So that is known as impeller. So here you can see this is the part known as 3-point linkage. So here is the PTO, and these are the 2 bottom links, and this one is known as top link. It has 3 links. So with the help of the 3-point linkage only, the tractor can operate this type of implement. So here the rotational power by the engine is taking from the tractor, and you can see its position can be controlled with the help of the tractor 3-point linkage. So we'll go back to our working note. So here, as I mentioned you, so we are using PTO, the power takeoff device, to take some rotational power out from the tractor, and so we can use that rotational power sometimes for operating a water pump, or sometimes we can use that power to operate the compost spreader as given in the video. Even we can use the rotational power to operate large grass cutters as well. So the most usual three examples are operating engine-driven water pumps. The uses of the PTO are operating engine-driven water pumps, operating compost spreader, and for control operating large sizes weed or the grass cutters. And then we'll move to the land preparation implements. So for that one also I'm using some videos. Give me a minute. So now we are discussing about the land preparation implements. So here you can see the implement that is known as disc plow. Normally we can divide the land preparation implements into two categories: primary land preparation implements and the secondary land preparation implements. So you can see here, normally we can divide the land preparation implements into two categories: primary and secondary. So this is known as disc plow, and that is a primary land preparation implement. Primary land preparation means breaking large soil pan, hard pan of the soil into bigger particles or into larger particles. So you can see this disc plow does that because it breaks soil into larger particles. And here also you can see how that device or the implement is handled by the tractor 3-point linkage. There will be another video that will clearly show you how it drags the implement through the 3-point linkage. So you can see here the things are break into larger particles. So even here also you can see the 3-point linkage. So the implement connects to the tractor through the 3-point linkage. Here no any rotational power is taken from the tractor, just tractor provides the drag force only. It only drags the implement on the field. And there's another important thing. So only at the end of this implement, there's a special wheel known as furrow wheel. So you can see that special wheel. So can anyone tell what is the basic function of that furrow wheel? Because others are discs. So they are breaking the soil. But at the tail end,
එකම මට්ටමක තියන්
ඔව් එකම මට්ටම කියන්නේ මේ වීල් එක හින්දා තමයි මේ ට්‍රැක්ටරේ ඉම්ප්ලිමන්ට් එකයි පැත්තට යන්න නැතුව ෆරෝ එක ඇතුළෙම ගමන් කරන්නේ. දැන් මේක තිබුණ නැත්නම් එහෙම ගොඩක් වෙලාවට සිද්ධ වෙන්නේ අපිට බලන්න පුළුවන් මේ. So you can see if there's no any furrow wheel, so the tractor here you can see that. I will show you. Tractor always tries to move this way, and here you can see the implements. So these are having this type of angle. So they try to move on this way. So finally, what happened? The tractor can't move along a straight line because the tractor and the device are having different directions. දෙන්නට direction දෙකක් තියෙන වෙන්නේ පැත්තට ගමන් කරන්න බලනවා. So that side movement is limited with the help of the furrow wheel. So with the help of the මොකද
මේක භූමි රෝධය කියන එකද?
ඔව් කියන්නේ මොකද? භූමි රෝධය කියලා ගන්නත් පුළුවන්. අපි කියන්නේ furrow wheel එක කියලා නේද? සිංහල නම තමයි දන්නේ. අපේට අනිවාර්යයෙන් furrow wheel එකකින් තමයි මේක මේ කෙලින් යන්න පුළුවන් වෙන ට්‍රැක්ටර් එකට. With the absence of that furrow wheel, tractor can't drive along on a straight line. So just only this furrow wheel, it can be driven along a straight line. So two things are happening, just breaking soil into larger particles while keeping the tractor as straight by the help of furrow wheel. So here you can see just a disc plow. It is a primary land preparation implement, and it just uses only the drag force by the tractor. And it is handled.
කට්ටෝරිස්තරේ විශාල අංශු වලට කඩන එකද කරන්නේ?
Oh, primary land preparation කියලා කියන්නේ ලොකු දැන් මේකට අපි කියන්නේ hard pan එක කියලා soil. So soil hard pan එක ලොකු කැලි වලට කඩන එක තමයි primary land preparation implement එකේ කරන්නේ. So disc plow එක තමයි හොඳම උදාහරණය. So you can see it is breaked into larger particles. And here you can see the 3-point linkage as well. So there's another video which also shows the same thing. This one also shows you how the disc plow works. And here you can see how it is fixed to this 3-point linkage. The top link, this is the top link, and there are two bottom links. This is the one known as top link because it is connected at the top, and there are two lower links. So these are the two lower links at the bottom. Altogether, there are three links. That is why it is known as 3-point linkage. And you can see the disc plow, and there's a furrow wheel. So you can see here, with the help of the furrow wheel only, it can have a straight drive. Otherwise, it would have an angular type motion, and definitely it would have a side motion at the pterodactyl. And while holding using the 3-point linkage, the disc plow is operated on the ground. So you can see. So by using this one, that is break into larger particles.
මෙහෙම කරනකොට bulk density එක අඩු වෙනව නේද?
Bulk density. අපි දැන් soil structure එක වෙනස් කරනවානේ. එතකොට අනිවාර්යයෙන්ම ඒකත් වෙනස් වෙනවා. Structure එක වෙනස් වෙනවානේ කොහොමද implement එකකින්. ගොඩක් වෙලාවට දැන් primary land preparation එක implement එකට වඩා secondary land preparation implement එකකින් තමයි ලොකුම structural difference එක වෙන්නේ. මොකද here using this disc plow, the soil is break into larger particles. If we take a secondary land preparation implement, that one further reduces the particle size. That means if we take a secondary land preparation implement, it breaks those larger particles into smaller ones. So as the next one, we'll see a secondary land preparation implement. We'll secondary preparation implement. So normally, harrowers are known as secondary land preparation implements. Here you can see a spring tooth harrower. It just shows you how it is designed and constructed as well. අපි ගොඩක් වෙලාවට secondary land preparation instrument එකත් එක්කම land level කරන්නත් පුළුවන්. මොකද ගොඩක් පොඩි කැලි වලට soil එක කැඩිලානේ තියෙන්නේ. So we can do both processes simultaneously. It means leveling and the secondary land preparation. So this shows you that type of collective equipment. The secondary land preparation implement, here the spring tooth harrower plus the leveler. So you can see that one. So here you can see closer to the tractor, we can see the harrower part, and at the tail part you can see the soil leveler. So you can see now the larger particles are break into smaller one, and finally it levels the ground as well. And this type of implement is known as a secondary land preparation implement because it breaks those larger particles into smaller ones. In addition to that, this one also has a leveler as well. So with a single motion, it can complete both tasks together. Means secondary land preparation as well as leveling. So you can see the larger particles are brought into a smaller one. Then at the end, tail end, it also levels. It also levels the ground as well. So you can see there are a lot of large particles. After moving it, so you can see it breaks those larger particles into smaller ones as well as it levels the ground as well. Second land preparation. Here also, so that is also hold with the help of a 3-point linkage. So you can see this is the 3-point linkage. With the help of that linkage, only the tractor can hold this implement. And here also, just the tractor just provide only the drag force on the tractor at the otherwise it doesn't give any rotational power to the implement. But there are some implements they are using tractor rotational power as well. So that type of implement we can categorize as a one which does both primary and secondary tasks together. So සමහරක් ඒවා තියෙනවා ඇදගෙන යන ඒවට අමතරව tractor එකෙන් rotational power එකක් ලබා ගන්න. The best example is a rotary plow. If we take a rotary plow, at the same time it can complete both primary and secondary tasks together. But it requires more power because in addition to the drag force, it also requires rotational power from the tractor. That means it takes rotational power from the tractor P2. And that type of implement is known as a rotary plow. So which can be considered as an implement which completes both primary and secondary land preparation tasks together. So we'll see that one now. So here now you can so here now you can see a rotary plow. So you can see now it takes rotational power from the tractor PTO here, and it has a blade set. So the blade set completes both tasks together. It means it completes primary land preparation as well as secondary land preparation at the same time. Because in addition to the drag force, the tractor also gives some rotational power through the tractor PTO. And this device is known as rotary plow. Make අපි කියන rotary plow එක කියලා. the special thing is it completes both primary and secondary tasks together, but it requires additional rotational power from the tractor PTO. Not like in the spring tooth harrower and the disc plow. So you can see in the single pass, so now it has braked soil into very fine particles as well. බලපුවම පේනවානේ පොඩි particle වලටම කඩලා ඉවර කරලා ඉවරයි. But if we take a disc plow, it first breaks the soil into larger particles. Then we need to use a harrower to break that larger particles into smaller ones. So we'll go back to our working note where we can put them into our working note as well. So here, normally external implements are connected to the tractor through the tractor PTO. So it is named as 3-point linkage because it has 3 links, 1 top link and 2 bottom links. Altogether there are 3 links. That is why it is named as 3-point linkage. And normally land preparation implements can be divided into 2 categories. Primary land preparation, it breaks soil hard pan into larger particles. Example is this plow. And if we take secondary land preparation implement, those larger particles can be broken into smaller particles with the help of secondary land preparation implements. And if we take a disc plow, it is a best example for a primary land preparation implement. And if we take the plow, then you all can remember there was a special wheel other than the disc that is known as furrow wheel. With the only help of that furrow wheel only, the tractor can drive on a straight way. Otherwise, it has a side motion. So then we discuss about spring tooth harrower. In here, we discussed a spring tooth harrower plus a soil leveler as well. So here, so with the help of a harrower and a leveler, again, both tasks can be completed. Means breaking larger particles into smaller ones, as well as leveling that ground as well. So by combining a leveler, we can do that one. And then finally, we discuss about there are some implements. Best example is a rotary plow. So which can be used to do both tasks at the same time. Both tasks means primary land preparation and the second land preparation. But so if we consider the harrowers and the disc plow, it only requires drag force by the tractor. But now if we are using a rotary plow, because it is doing both tasks together, it other than the drag force, it requires rotational power from the tractor PTO as well. And yes, I think that is all about the implements that we have to discuss today. And at the same time, so that is all about the things we have to discuss as well. So I will share this one with you. I think I have previously also I have shared this document with your batch rep. So even today also I will share this one with you. And when you are preparing for the exam, just go through the working notes that I have given to you. And you may have some MCQs, and the knowledge that you are taking from the note is more than enough to do those MCQs. So if you have any questions, you can put them into the chat or you can directly tell them. ගැටලු මොනවද තියෙනවද? මම මේක ෂෙයා කරන්නේ. ගැටලු මොනවද තියෙනවද? We have also sharing my email and contact number as well. So here I have shared my phone number and the email address. So when you are preparing for the exam, if you have any question regarding the materials I have given here, so please contact me. Okay. පක්කර ගැටලුවක් තියෙනවා නම් කතා කරන්න. මම මේ working note එක share කරලා ඇත්තේ මම හිතන්නේ batch එක මම ආයෙ පාරක් batch එක දාන්න. පොඩ්ඩක් batch එක හරි කවුරු හරි පොඩ්ඩක් මේ කතා කරන්න දාලා නැත්තම් එහෙම මම ගාව batch එක පොඩ්ඩක් ආයෙ මට කතා කරන්න හරිය මම හිතන්නේ යාගේ email address එක අරගෙන මේක share කරන්න. පොඩ්ඩක් වෙලාවට LMS එක වැඩ කරන්න නැති වෙලාවල් එනවා මම හින්දා මේක email කරන්න. So හරි ගැටලු මොනවද තියෙනවද අපිට ගැටලු නැත්තම් මේක ඉවර කරන්න පුළුවන් නේද? So if you do not have any questions, so thank you very much for being in this session. So if you have any matter, so please call me or mail me, so then I will help you. So thank you very much for being in this session throughout the day.